Very good afternoon, everyone. Myself, Dr. Deepak Kumar Singh, and currently I'm working as an assistant professor in Amity School of Engineering and Technology, Amity University, Patna. And the title of my presentation is Finite Element Analysis of Two Box Gutter Bridges. So these are the content of my slide. I will start with the introduction of the problem, then which methodology I have chosen, so that I will discuss, then some results I will show, and after that, finally, I will conclude the presentation. So starting with the introduction, so we may see different kind of bridges in our locality. So most of the bridges are straight bridges, but if there is a constraint, some limitations of spaces may be there, some constraint of traffic, the territories may be mountainous. Okay, so we have to divert the road. So in that cases also we have to um, just make some bridges. So in that the flow of traffic and the abutment is not perpendicular. So in that case, that is little bit tilted, and that is the tilting angle is known as the skew angle, and these bridges are known as skew bridges. The second thing is box cutter. So box cutter bridges are prepared uh, to save the material. Okay, the static view is good. Torsional rigidity is also increased because the material is just uh, sent outward. The torsional rigidity is also good. Okay, load distribution is also good. Okay, uh, so it is more preferable than your state building, and that I will just go or just conclude by the results which I will show. So about the methodology, I have used finite element method, and for that I have used CSI bridge software, which is based on the finite element method. And this bridge is reinforced concrete bridge, box cutter bridge, and the diagram, the cross section of that bridge is shown here. Okay, so a single cell box cutter bridge is there, and on both the side curve is there. You may also refer that as a railing, and beyond that we have footpath is there, and at the side center carriageway is there, that is pavement on which the vehicles or the other people may just move. So we can see we have two vertical members in that box girder. So one is referred as inner girder and the other is referred as outer girder, because we are in India, so we just follow the left hand side driving. So the left hand side girder is referred as inner girder, and the other one is referred as outer girder. So that is like that, and the other terminologies are also given. So because this is report cement concrete box cutter bit, so we have used two materials basically. So first one is concrete. So for concrete, I have used M40 grade concrete. So the characteristic strength is 40 megapascal, poison phase is taken as zero point 0.2, density is taken as 2400 kg per meter cube, that is 24 kilonewton per meter cube, and the modulus of elasticity is taken as 3.16 into 10 per 7 kilonewton per meter square. That can also be calculated as specified in IS 456, that the value of elastic modulus is 5002 FCK. FCK is the characteristic strength. Then for the steel, we have used Fe 500 grade steel. So the yield strength is 500 megapascal. The density is taken as 7800 kg per meter cube. So that is 78 kilonewton per meter cube. The acceleration due to gravity I have taken as 10. So that's why that is 7800. And elastic modulus is taken as 2 into 10 per 8 kilonewton per meter square. So these are the metal properties and the methodology which we have used. Now about the boundary conditions. So at the abutments, the bridge deck is simply supported, and we have actually applied three kind of loads which are specified in IRC, Indian Road Congress 2000. Three different kind of loading conditions, but the effect which is maximum by applying the 70 R crack load. So I have only presented the results after applying this 70 R crack load. And because this is finite element modeling, so we have to use some element. So in that, we have used four noded plate element, which has 6 degrees of freedom at each node to discretize the whole box girder or the deck, the inner girder, the outer girder, and the lower part of the box. And before proceeding, before just evaluating the results, we have to uh, make a convergence study. So convergence study is basically to find the optimum size of the map. If you just see the diagram, so deflection is plotted against the mesh size, and after the mesh size of 100 mm, the results are converged. So the mesh size of 100 mm is taken, and the further results are computed. So the aim of the present study is to investigate the effect of skew angle and span depth ratio. Two things are varied. One is skew angle and other is span depth ratio. But span is taken or fixed at 35 meters. So basically the depth is just changed. For the results, bending moment, shear force, vertical deflection, and torsion moment is evaluated and the deck is or the bridge is just subjected to dead or live load. So both the results are computed independently. So these results are for the bending moment ratio, and this is subjected to dead load, only dead load. That is, no vehicle is moving on the bridge. Only the weight of the bridge is taken into consideration. So we can see that when the skew angle is increased, the dominance of bending moment is decreased in both the cases. For exterior girder, that is the outer girder, or for the interior girder or the inner girder. And with changing the L by D ratio, that is span depth ratio, L is the span, D is the depth, it is also decreased. And for this variation of bending moment ratio, both the external and internal girders, the results are quite similar. Now, if we just talk about the live load, if we just apply the 70 R track load on the bridge deck, so in that case, again the results are decreasing with the increment of skew angle as well as the L by D ratio. But for the when the skew angle is increased, the results are increased. It is not decreased for the exterior girder, but for the interior girder, it is increased, but the increment is not so prominent. The results are almost around each other. Now, for the shear force ratio for the dead load, if the skew angle is increased, the value of your shear force is increased, and in both the cases. And when L by D ratio is increased, the results are increasing, but not significantly. This is for the dead load, and the same results are for the live load when the bridge is subjected to 70 R track load. And again, the similar kind of pattern is just observed, that the results are a little bit far away in case of exterior girder, and for the interior girder, it is quite closer. Now, these results are for the torsional moment. When the bridge is subjected to only the self-weight, that is the dead load of the bridge structure. And again, the same pattern is again observed, that when the skew angle is increased, the value of your torsional moment is increased. And with that L by D ratio, that is span depth ratio, again the results are increasing with the increment of the span depth ratio. That is basically the depth increase. Now, these results are for the live load, and it is almost the same when we just increase the span depth ratio. But when the skew angle is increased for a particular span depth ratio, the results are decreased. These results are for the dead load, in which the vertical deflection is computed, and the same pattern is again observed in both the exterior and interior girders. And now, in case of vertical deflection ratio for the live load, when the bridge is subjected to 70 yard crack load, so the results are again showing the same pattern. For the interior girder, the results are quite closer. Now, after going for computing all the results, some equations are proposed for different, that is bending also, for shear force, for torsional moment, and vertical deflection. And in that, the two variables are there. One is theta, that is Q angle, and the other is L by D ratio. So if we just put the value of your Q angle and L by D ratio, we can directly compute the value of the different forces and deflection directly. We don't have to go for the analysis. Now, these are the conclusions. So the influence of Q angle on the forces and deflection is not significant up to the 30-degree skew angle. So up to 30 degrees, we can analyze our bridges as a straight one. So the analysis is quite simple for the straight bridges. So we can, up to 30 degrees, we can analyze our skew bridges as a straight bridges. Now the effect of skew angle on force and deflection in both the girders due to dead load is considerable, but due to live load, it is not considerable. But yeah, it is varied. Now, for the bending moment ratio, which is decreases slightly with the increment of span depth ratio for the straight bridge, but it decreases further considerably with the increment of skew angle. So, skew bridges have more L by D, attract a lesser bending moment. So, these bridges, which is having skew pattern and which have more L by D ratio, that is preferable and beneficial than the straight bridges. Now for the shear force ratio, which increases slightly with the L by D ratio. However, for the skew bridges in both the girders, it increases, but for both L by D and for the skew angle, in both the cases, it is increases. And TMR is in the outer girder, it decreases as the L by D ratio increases, but it increases in the inner girder, that is in the interior girder. Now for the vertical deflection ratio with the L by D ratio, the skew bridge has less deflection than the straight bridges, so it is quite preferable than the straight bridges. So these are the references, and thank you so much.
Yeah, Dr. Singh.
Yes.
Can you hear me? Yeah.
Yes.
Yeah. So first, you start your video. Those who are going with the presentation,
Okay.
it is mandatory that they have to keep on their video.
Actually, yes.
And
Actually,
yeah.
it is on, but it is not showing. I don't know why. I'm just yes.
Okay. Now you are visible. Now you are
Yes.
visible. And second, to all the panelists, those who have joined, they have to constrain their presentation between 10 to 12 minutes because time limit is there. So try to finish it within the time limit, and 2 minutes will take for the question hour. Now, presentation was really wonderful, and only one question I would be asking: what was the
Yes.
main motivation behind going for this particular topic, skew bridges that you have taken? Because very few work has been done. So
Actually, yes.
was
Yes, that work has been done. That was the PhD topic of my co-author, and the motivation was there that because we have some constraints, because we cannot just make a bridge in a straight direction. Okay, in some cases we have some constraints, some traffic constraints. Maybe there some mountainous road is there. So in that case, we have to just change the pattern of the bridge. So in that case, we have to move from straight to the skew one. We have to tilt the direction. So that was the motivation. And the other part, that is the box cutter bridge. Box cutter bridge is now preferred in India because in that we can save much material and the stability and strength is also pretty good compared to the solid bridges. So that was the motivation behind this topic.
Okay. So it was a really good presentation delivered by yourself. Now we will move to our next panelist. Yeah. Who is the next one? Please be prepared and keep on your video.
Thank you, Deepak Kumar, sir. Ms. Shivangi, are you ready for your presentation?
Thank you.
Yeah, sure. Okay, good afternoon, everyone. Is my screen visible?
Yes, ma'am, it's visible.
Okay, sure. So good afternoon, everyone. Myself, Shivangi from Amity School of Engineering and Technology. And the topic of my presentation is comparative study of effect of vertical stiffness at 30%, 50%, and 70% irregularity on the nature of frame structures. So to start with, first of all, we'll be seeing the introduction. So basically, we have analyzed 290 moment-resistant frame structure, half with masonry infill and half without masonry infill. For masonry infills, we have infill as a diagonal strut in accordance with IS 1893 Part 1 2016. Further, we have done analysis and design using response spectrum analysis for regular frame without stiffness irregularity. After this, we have introduced stiffness irregularity in the form of story height, and we have kept irregularities as 30%, 50%, and 60%. And slowly we have shifted the irregularity in the different stories for both masonry infill structures and without masonry infill structures. And at the end, we have analyzed and designed using response spectrum analysis, ATC 40 and FEMA 356 for all the zones in accordance with Indian standard. And we have obtained time period, base shear, and lateral displacement. And finally, we have done the comparison and the conclusions. Coming to the literature review. So based on the literature review, the following results were obtained and a critical summary based on literature is summarized below. Basically, presentation of simple computer-based pushover analysis technique for performance-based design of buildings subjected to earthquake loading has been done. And the present study develops a pushover analysis procedure based on a non-linear post-elastic material model, which provides the capacity to monitor initial yielding and gradual progressive plastic behavior of both individual elements and overall structural system. The behavior of multi-storied building has been investigated in terms of force displacement relationships, inelastic behavior of structure, and subsequential hinge formations. Coming to the problem formulation. So after doing a rigorous literature review, we have done the formulation. So we started with the modeling of two models. The first one is with masonry infills and the other one is without masonry infills. So basically, these two models were designed in SAP software, and we have designed this strut instead of indicating the masonry infill, and the dimension came out to be 540 cross 230 in mm. And a G+11 story 2-dimension moment resisting frame structure with and without masonry infill was modeled in SAP software. After this, After the analysis is completed, we have again analyzed 96 models. And in this, first we have introduced 30% irregularity, vertical stiffness irregularity in the form of story height. So basically, one by one, we have introduced 30% vertical stiffness irregularity. And we have done the analysis for both without masonry infill and the structure with masonry infill. After this, another set of 96 models were analyzed with 50% vertical stiffness irregularity in the form of story height. And this is the model we have obtained. And again, 96 models were analyzed. And this time we have introduced 70% irregularity at each floor for both structure with masonry infills and without masonry infills. Coming to the methodology, so we have started with the literature review and followed by knowing the research significance and further understanding nuances of response spectrum analysis and of pushover analysis as per FEMA and application to IS 1893-2002. Further, we have defined relevant properties, load patterns, and load combinations. And finally, pilot modeling of the structure has been done by validation and verification. Further, we have done creation of structure models for pushover analysis after designing the structure using response spectrum in SAP 2000 software. And we have introduced vertical stiffness irregularity in the form of story height in the multi-storied RC frame structure, followed by pushover analysis. Further, we have introduced vertical stiffness, vertical irregularity in the form of story height in the RC frame structure with masonry infill, followed by pushover analysis. And finally, quantification of outcomes and conclusions were done, and paper publication and reports were made. Coming to the results and discussion. So after doing the analysis, the result of response spectrum and pushover analysis using ATC40 and FEMA 36356 for structure model in seismic zone 2 to 5 has been shown. So these are the two tables. The first one is representing performance point for the regular frame structure without masonry infill. And the second one is introducing with masonry infill. So we have taken all the zones, zone 5, 4, 3, 2. And the type of structure which we have taken is important structure. So we have taken I as 1.5. Reduction factor we have considered as 5. Zone factor in accordance to Indian standard we have taken for different zones. And then we have calculated scale factor for different zones. And using the software, we have received time period for mode 1 in seconds. These are the time period. After that, when we have done response spectrum analysis, these are the base shear we have got, and these are the displacement we have got. Further, when we have done pushover analysis in accordance with ATC40, these are the base shear we have received, and these are the displacement. And in accordance with FEMA 356, these are the output we have got. Similar thing has been done for the structure with masonry infill. Now, secondly, coming to the time period. So time period has been obtained for different percentage at different percentage of irregularities, that is 30, 50, and 70. One for without infill and with infill. So these are the time periods which we have received. The next one we have received is a base shear, which is obtained as per response spectrum analysis, ATC40 and FEMA 356. And these are the result for various zone, like at 30% irregularity, 50 and 70% irregularities at different stories. And in this presentation, we have only shown zone 5. Similarly, we have received for 4, 3, 2. And these are the graphs showing for 50% irregularity. And finally, coming to the conclusion. So the first one is influence of infill on base shear of frames without stiffness irregularity. So first we can see that base shear using response spectrum for frame with infill and without vertical stiffness is 1.47 times more than that of the bare frame, that is frame without masonry infill. Similarly, pushover analysis to gives higher base shear for structures with infill when compared to bare frame. And when we have done pushover analysis using ATC40, we got base shear as 2.47 times, which is more than that of the bare frame. Whereas we have received in accordance with FEMA 356, we have received as 2.72 times. When talking about the displacement in accordance with ATC40, we have got For masonry infill as 0.83 times more than that of the bare frame, and for 356 also it was 0.77 times more than that of bare frame, which indicated that resistance to displacement in infill frame is comparable with that of the bare frame. When talking about the influence of location of soft story on the time period of frames with stiffness irregularity, so as you can see within this narrow variation, it is clearly revealed that location of soft story has more impact on bare frame than infill beams or in frames. Now, when talking about the influence of location of soft story on base shear of frames with stiffness irregularity, so these are the values which we have received for bare frame with 30%, 50%, and 70% irregularity. These are for with infills. So finally, after analyzing numerous models in SAP software, it has been concluded that the structure with infills are safer when compared to structures without infills in different seismic zones of India. Hence, while doing seismic calculation, infill calculation should also be included, although many a times it is excluded in India. So these are the few of the references which I have mentioned and have been used for my study. Thank you. Anyone has any question?
Hello, am I audible?
Hello?
Yes, am I audible? Am I audible?
Yes, you are.
Yeah. Not a question, but I want to suggest something. Actually, the code.
Does anyone have any questions for Ms. Shivangi?
Yes. Hello, am I audible?
Yes, you are audible. Please go ahead.
Yeah. Actually, we
Okay,
have
thank you, Ms.
referred a
Shivangi.
code
Thank you.
1893.
Yeah, Mr. Sachin, can you please join through your laptop?
Sorry, madam, I have an access through only with this device. Will that be comfortable?
Actually, we are facing a lot of problem in being your screen. So it is suggested to please present through your laptop, and you have to keep your video on also.
Can I have another
What you
1
do,
minute,
you
madam,
arrange
so that I
for
can...
laptop, and after a few presentation, we will take yours.
Sure, madam. That will be very much thank you. Yeah, thank you very much.
Yeah.
As per the sequence, please, Mr. Prakash, can you present now?
Yeah, all the participants, you have to be ready as per the sequence that has been WhatsApp on the group as well as on the mails.
Since Mr. Sachin is trying to reconnect, could Mr. Prakash present?
Okay. Hello. Hello.
Dr. Priyanka, how many presentations we have in this session? Hello.
Hello. Yeah, who is this?
This is Dr. Shiva from CBRS.
Yeah, Dr. Siva. Yeah.
How many?
What's your paper ID?
No, I am the session chair here.
Okay. So
How many
welcome to
presentations we
this
have?
track 3 of TRACE 2022, and up till now 2 presentation has been carried
Yeah, I was the total. I'm asking you how many presentations we have for this total.
Carried out, and we are going with the third presentation.
Yeah, please.
Yeah, Dr. Siva, we have 8 to 10 presentation piled up in this
So we
track.
have total of 8 presentations in this session.
Okay, fine, fine. Please. Thank you.
Hello.
Yeah, Prakash, continue with your presentation.
I'm audible now.
Yeah, perfectly. Go ahead.
Good afternoon, ma'am.
Yeah, good afternoon.
So the topic of my presentation is finite element
Your screen is
analysis.
not visible to me.
My screen is not visible.
Yeah. Anyone else who can see the screen of Prakash?
Yes, it is visible.
Okay, so might be some problem in my network. Yeah, go ahead.
Okay. So the title of my paper is finite element analysis and design of concrete bridge deck reinforced with GFRP bars. So the contents are introduction, problem formulation. So the introduction is a major maintenance expenditure for various transport departments is the replacement of bridge decks, which is due to the corrosion that is induced in the reinforcement in those decks. So a potential solution to this deterioration in a reinforced concrete structure is to use FRP rebars, fiber reinforced polymer rebars. They are corrosion free, they are light in weight, they have higher tensile strength compared to steel. And there have been many experimental studies also regarding this FRP rebars in concrete structures. But there have been few practical applications in bridge decks of GFRP rebars. So the problem formulations in this study, a theoretical design of GFRP reinforced concrete bridge deck is prepared, which is then modeled and analyzed in finite element analysis using ANSYS software. And then a detailed design of GFRP reinforced pedestrian concrete bridge deck is proposed. This is the literature review, the learnings from the literature review. Some learnings are that the FEM is capable of predicting the behavior, the carrying capacity, and the mode of failure of bridge deck slabs reinforced with FRP reinforcement. After the serviceability performance of concrete deck slab reinforced with FRP rebars in terms of strain, crack, and deflection were very similar to that of steel rebars. The GFRP reinforcement ratios, that is 1.2% in bottom and 0.6% in remaining 3 directions, are adequate for satisfying the serviceability criteria and strength criteria required as per the Canadian Design Code. And the maximum tensile stress in bottom GFRP at service loads are less than 5 megapascal, which is less than 1% of the ultimate tensile strength of GFRP rebars. In methodology, first, a theoretical design of the concrete bridge deck reinforced with GFRP is prepared. These were some assumptions that were taken, like the location that was taken was Haryana of India. After that, it was a cast in situ type of construction. The loading that was considered on the bridge was only pedestrian load, and two-wheeler traffic, that is very light load, is considered. The total length of the bridge is 20 meters. There are 3 spans of 6.8 meters each. The clear span is 6 meters. The width of span is taken as 2.3 meters. After a theoretical design was prepared, finite element modeling and analysis were done. 2 mutually exclusive vertical loads were taken as per the IRC code. The crowd effect on the bridge is represented by a UDL. Loading of 5 kilonewton per meter square is as per IRC guidelines. A 10 kilonewton concentrated load was also taken as maintenance load, which was exclusively used to analyze the bridge deck. These are the engineering properties of the GFRP rebars, like modulus of elasticity, ultimate, that was used for the finite element analysis of the slab element. This table shows the results that were obtained from the theoretical design as well as finite element analysis of the concrete bridge deck, which was reinforced with GFRP. The theoretical design was prepared as per the ACI 440 code, and these results were obtained. Like maximum deflection as per the theoretical design was 1.51 mm, maximum shear force was 66 kilonewton, maximum movement was 83 kilonewton meter. From FEA, we got results as maximum deflection was a half of the what was as per the theoretical design, which shows that the theoretical design was very conservative. Maximum shear force obtained was 54 kilonewton. Maximum movement was 57, and maximum stresses that were observed in the concrete was 18 megapascal, which were very less, which were within the concrete strength. This figure shows the deflection output as taken from the ANSYS. This graph was taken from the ANSYS. It shows the deflection of the bottommost longitudinal fiber for combined dead load and live load. The second figure shows the equivalent stress output from the finite element analysis of bridge deck. It gives the value of the stresses that the concrete is facing. Then the conclusion. Based on the findings of the study of GFRP reinforced concrete bridge deck slab for pedestrian load, the FEA model successfully predicted the stresses developed in GFRP reinforced concrete bridge deck slab for the applied dead load and pedestrian loading conditions. Additionally, by conducting the FEA on concrete deck, the practical effectiveness of GFRP rebar in bridge deck was cross-checked and found to be satisfactory. A reasonably good correlation between literature study and FEA results of the model were observed. The maximum shear stress during theoretical design was found to be 65 kilonewton, which is 15% more compared to shear stress results observed in FEA. The maximum bending moment is observed at longitudinal edges, and the maximum shear force is obtained at the support. The stresses in longitudinal reinforcement at edges were 0.83% more compared to stresses in longitudinal reinforcement at midspan, while the strain at edge reinforcement was 0.8% more compared to strain in center span, validating a linear relationship. The theoretical designs were found to be conservative than the results obtained from FEA. Thus, the final proposed design was improvised considering the results obtained from FEA, so the design becomes more cost efficient. These were the references that were used. ASTO guidelines were used, ACI codes were used, some IRC codes, IS codes were also taken into consideration while proposing a theoretical design of this bridge deck slab. Thank you. Hello.
Hello.
Yes.
Prakash,
Yes, sir.
I have a question.
Yes, sir.
So what is the significance of this topic?
What is the
Significance of this work?
Sir, in this work, first a theoretical design was prepared as per the ACI codes, considering the Haryana region. Currently, there is no work done using GFRP reinforcement in bridge decks in India. So, according to Haryana region conditions, a design was prepared. And this design, the detailed design will be submitted to the PWD department in the Haryana region in the Mahendragarh area. We were in talks with them, and a detailed design will be submitted to them, and they will consider it to be constructed over canals. Some canals, there is some canal lining work going on over which pedestrian bridges can be made. So, as per trial, this bridge can be made there.
No, it is already available, like in New Zealand and Australia. They are following this.
Yes.
And
in other countries, they are there are cases of GFRP reinforced bridge deck, but in
Okay,
India
and
there is
okay, let me complete. And especially in your case, you are telling that you are proposing for Haryana region.
yes, sir. Yes.
What is the difference between Haryana?
Sir, first thing, the temperature regions.
Any
the
other places?
Yes, sir.
You are specifically telling that you are proposing this for Haryana region.
Yes, sir. The temperature area, the earthquake area, those regions, as per if any assumption is required according to region, so Haryana condition will be taken. Haryana, the data of Haryana will be taken.
So have you considered the seismic force?
No, sir.
So you have considered only the static and
Sir,
you have considered
currently the structure is only the this design is only of the superstructure. The substructure part is separately designed.
So you have only tested that, conducted the numeric analysis for.
Sir, this paper is only about the superstructure part.
Okay. How did you ensure the proper bonding between concrete and GFRP reinforcement in your model?
Sir, there were there were many problems regarding that. So for GFRP in new version of ANSYS, there is a separate option available that the reinforcement can be put as a reinforcement. We don't have to use any coding. We don't have to make it a link of 180. We don't have to.
No, I'm just talking about the interaction between concrete and GFRP.
It takes it automatically. The new version of ANSYS, the 2000.
Okay, what is the strain? What is the strain value you have taken for GFRP reinforcement?
Strain values. Sir, the stress strain graph that I have taken for the GFRP. So wait a minute, I'm sure. These are the value stress strain of the GFRP that I have.
I'm not able to see that.
Wait a minute, sir. Is it visible?
Yeah, fine.
So this was the stress strain graph of GFRP that was incorporated into ANSYS.
So you were telling it is going up to in linear phase.
Yes, sir. Yes, sir. The GFRP goes linearly.
GFRP goes linearly.
Yes.
So what will happen after the yielding?
So there is no yielding.
Yeah, that's what I'm asking you. Suppose if yielding occurs.
Sir, the bridge deck is designed so that concrete crushes first. The GFRP will not yield. The GFRP will not reach the ultimate strain. Concrete will crush first, so that the structure will not fail.
Okay. Okay, fine.
Okay, sir.
Thank you, Mr. Prakash. Now I would like to call Vinayak Gautam. Vinayak, are you ready?
Hello, sir. This is Sachin. Shall I join afterwards?
Okay, Sachin, you can present your presentation.
Okay, thank you, sir. Good afternoon, everyone. Good afternoon, everyone. I'm Sachin Vijay Kumar. I'm an assistant professor at NIE, the National Institute of Engineering, which is in Mysuru, Karnataka. And today I'll be presenting my MTech students' work, which is on analytical studies on the fire resistance of reinforced concrete beams exposed to parametric time temperature curve. So in this work, these are all the contents which I will be presenting today. So basically, an accidental fire in a building is a severe environment, so which a structural element can be exposed to, so under which there will be a spontaneous increment in temperature. So due to which the elements undergo thermal expansion, and there will be loss in stiffness and degradation in strength. Also, structural elements exposed to fire undergoes deterioration in material properties. So hence an accident may lead to the total collapse of structure. We have seen that also. So in order to overcome this catastrophic collapse, elements must have fire resistance. So when we look into various literatures, a series of numerical and experimental analysis can be found on RC elements. So in which the fire resistance of, if you have
Sachin, can you please switch on your camera?
sorry.
Yeah, all the participants, those who are presenting, they have to keep their video on.
Am I visible? So there is a problem with the camera.
Yeah, please proceed.
Am I visible now, madam?
Yeah, Mr. Vinayak, can you please mute yourself? Yeah, you can continue, Sachin.
Yes, thank you. The fire resistance of RC beams, if you look into the various literatures, it is going to vary with the grade of concrete that will be utilized. However, it is maximum. It is found that it will be maximum with normal strength concrete. And also that is going to vary with axially restrained conditions. And also, not only the material properties that is influencing the fire resistance, it is also the outer environment, such as fire exposure period, fire exposure surfaces, and type of loading that is there on the RC elements that is also significantly going to affect this fire resistance. So when we have such kind of behavior, so we will be having very finite number of options to determine the fire resistance in a regular day-to-day design basis. And we have a hands-on practice by Eurocode, that is 500-degree isotherm method. So it is found that the influence of clear cover is significant with rather than this grade of concrete on the RC elements. And also the duration of heating phase is one of the concept which is developed by M. Franzen to analyze or assess the fire resistance of RC beam when it is exposed to parametric time temperature curve. A parametric time temperature curve is the one which has the cooling phase of a fire. However, the one which we are considering in IS 456 or any of the IS standards, the guidelines which has been provided, it is only for the standard time temperature curve. For example, if the diagram, if you can see, the one with the orange color is standard fire and the others are all parametric time temperature curve. So suppose in case of actual fire of this kind of nature, we should be utilizing the duration of heating phase condition to assess our structural elements. So these are some literatures which, if you focus on further, the fire resistance of elements in the given standard guidelines in IS 456 and also in Eurocode 2, we have some prescriptive conditions such as in order to enhance fire resistance, that is clear cover, width or depth of the member, or maybe the protective coating in case of steel elements. However, this is not considering the actual behavior of the fire, and as I said previously, it has been done only for time temperature curve analysis, having the standard conditions. The performance of elements is also being neglected in the codal provisions, such as the influence of material that we have used, or maybe the clear cover that is exactly utilized in that, or maybe the support conditions, which we will be which will be varying in the practices. So those things are the limitations of our IS 456 or maybe the Eurocode standards. the behavior of structural elements, either the part of the building or global behavior under these circumstances becomes very difficult to estimate. Hence, larger scope exists for us to determine the performance of individual elements or the total structure under the case of fire. So hence, we have taken this performance-based approach to determine the capacity of RC beams under the exposure of parametric fire conditions. So we have taken the simply supported condition because it is going to it is the most critical scenario when it is compared with other type of support conditions. Coming to the methodology, we have considered a finite element package, Abaqus, to conduct our thermostructural analysis. Under that, we have considered sequential thermostructural analysis, where the heat transfer analysis will be conducted first on the thermal model or maybe the element under the thermal scenario, and the information which is obtained under heat transfer analysis will be utilized for mechanical analysis. That is the second set of the analysis. And in order to conduct this, complete this finite element analysis, we have considered concrete to be under DC3D8 element and DC1D2 element in thermal analysis. However, it comes to structural analysis, it is going to vary with C3D8R and T3D2 element. Further, the combination of heat transfer analysis and mechanical analysis finally utilized to determine the behavior of the element under fire scenarios. So, and the required material properties to complete this finite element procedure is adopted from Eurocode 2. For example, specific heat, or it could be thermal expansion or thermal conductivity of either concrete or steel has been obtained from Eurocode 2. And we require damage plasticity model to be inbuilt for this kind of analysis. And we have taken the courtesy of Lee and Funvis for this. And the stress strain relationship utilized in finite element procedure is displayed here. However, after utilizing all these packages, we need to identify the failure of individual element, what we have considered. And that exposure under the condition of fire exposure, Eurocode 2 provides these kind of deflection failure consideration, and that we have considered for the failure of our elements. After utilizing these procedures, it is our need to determine whether the considered material properties understood methodology is working with the experimental model. So first we have verified with VKR Kodur and Ankit Agarwal. They have tested this kind of specimen in Michigan State University, and we have obtained hopefully approximately around 10% of error with respect to our analytical model and their experimental results. And yeah, this is another one, deflection behavior that we have obtained with validation. After completion of validation study, we have conducted parametric study, which includes 8 different types of elements. We have selected 4 elements in IS 456 and 4 elements from Eurocode. And here, the interesting thing is the width of these elements have been considered based on the guidelines provided by the set standards. And depth has been obtained by the deflection criteria by applying the load, which is I have included in the previous slides. So we have obtained this depth, and the consecutive reinforcement has been modeled into the finite element analysis. Later, these 8 set of elements were subjected to standard time temperature curve. The ideology was to determine the actual fire resistance of the beams and their comparison on to the variation of parametric time temperature curve. So, and when we apply parametric time temperature curve, there will be cooling phase. So we have to analyze only the heating phase. The heating phase is, for example, in figure 9, suppose if you look into the blue color line, the one which is having the maximum temperature, for example, around 1000 degree, up to that duration, we are going to consider only as duration of heating phase, and the remaining one will be neglected. So in such condition, we have determined the various duration of heating phase as the failure criteria under parametric time temperature curve, and the actual fire resistance of these beams under the application of two different types of loading, that is 40% and 60% loading conditions. So what is this 40% and 60% loading condition? It is the applied load during the fire accident that my structural element can withstand. So this is again 60% criteria is provided by Eurocode. However, for the better understanding, we have reduced that percentage to 40% also. So under these circumstances, if you look into the table 2, these are our results obtained after conducting this finite element analysis. So where the actual fire resistance of the considered beam, either it is Indian standard guideline or as per Indian standard guideline or Eurocode standard guideline, they are having higher capacity, even under the reduction of load, or even it could be the increment with the fire resistance. So we are having highest fire resistance capacity than what it has been stated by these guidelines. However, when we look into graphical representation, the comparison of Eurocode and IS code fire resistance property, Eurocode stands far ahead. They are having higher fire resistance capacity when it is compared to Indian code guidelines. With this example, we could able to understand. And also B5 and B6 are having highest fire resistance than what it has been stated. Later, if we understand with parametric time temperature curve, the amount of time which is only considered for a heating phase is matching here to the code specified fire resistance. That means, suppose if I look into this figure 9, my element specified by B2, specified as B2, B3, B4, considered by the guidelines of IS 456 is going to fail. I'm going to repeat, is going to fail before the actual fire resistance capacity is reached. So that is, this enables us to identify the element actual behavior is going to vary with the change in fire dynamics. And the beam elements have been suffered drastically under the exposure of parametric fires. And yeah, at the outcome, we are having the actual fire resistance capacity of reinforced concrete beams are higher than what it has been analyzed here. It is obtained to be higher, and the actual fire resistance of RC beams is considered as per IS 456 is less than the beams considered as per EN2, and we have more scope to advance these conditions. And also the RC beams B5 and B6 are having highest capacity. And overall, the set of outcome of this project is we need to consider the performance-based analysis of elements in order to make more sustainable structural element and as well as resilient structure. And yeah. And DHP can be utilized effectively to determine the deterioration of structural element under the condition of parametric time temperature curve. These are some of my references which I have considered for the presented work. Thank you, everyone.
Yeah, any question from the session chair?
So very good afternoon. It's a very nice presentation, Professor. And just one small,
Thank you.
yeah, like obviously the conclusion is well known. So what's the significance of this?
Significance is, if I have to say, sir, at present we are having prescriptive guidelines on the fire resistance of structural elements, which is not considering the effect of fire. We don't know whether the considered practicing elemental dimensions or maybe the material properties is actually providing us the required fire resistance or not under the actual behavior of fire. So we need to advance our available information or the knowledge in the guidelines. Maybe the example is one is IS 456 needs to take it up ahead towards the performance-based analysis to the extent possible. So that is the need of this work, sir. Yeah, significance of this work.
Okay, fine, Professor. Actually, for your concern, the 456 is under consideration for upgrading. So soon we will get the upgradation.
Can you be louder, sir? Sorry.
So it's fine. It's very good. And for your knowledge that IS 456 is getting upgraded. So hope we can expect the applications here.
Thank you.
Thank you. Thank you.
Thank you, Mr. Sachin. Now I would request Mr. Vinayak Gautam to start with his presentation.
Ma'am, am I audible? Hello.
Yes, you are audible.
please proceed.
Okay,
Yeah.
ma'am.
Yeah.
I request everyone to please wind up your presentation within 10 minutes. So accordingly, keep your speed. Thank you.
Ma'am, my presentation is visible.
Yes.
Okay. Good afternoon, everyone. My name. I will be speaking a little faster because the total number of slides are 52. These are my contents. So to begin with the introduction, the first introduction of the high-rise buildings. So IS 875 Part 3 2015 defines a high-rise building as building having a height more than 50 meters or having a height to smaller dimension more than 6. Home Insurance Building in Chicago is regarded as world's first modern skyscraper, which reached the height of 54.9 meters in 1891. Then came the period of 1960s, which ushered the high-rise construction into the domain of super tall buildings. Example, John Hancock Center building, which reached the height of 354 meters, One World Trade Center, 470 meters, etc. Then 1980s was the period which first introduced the concept of aerodynamic modifications in the high-rise building, which we will see in the upcoming slides to counter the effect of wind-induced vibration. On your screen, you can see two different buildings. On the right side is Standing Torso, which is a helical shaped building. It is a kind of major aerodynamic modification. On the left side, you can see Petronas Twin Towers, which employ rounded corners in their geometry. These are some of the factors responsible for growth of high-rise buildings, increasing population, scarcity of land, urban redevelopment, financial center, etc. Now we come to the definition of wind. So IS 875 Part 3 2015 defines wind as air in motion relative to the Earth's surface. So wind, the major cause of generation of wind is the pressure differences in the atmosphere, which themselves are caused due to differential heating of Earth's surface between equators and poles. So this differential heating in conjunction with the Earth's rotation gives rise to wind in the atmosphere. Next is the wind turbulence. So wind turbulence is caused when the layers of fluid, flowing fluid intermix with each other. This intermix, due to this intermixing, exchange of energy takes place in between the flow particles. This exchange of energy creates eddies or vortices in the wind flow, which is a defining characteristic of wind turbulence. It is measured in the terms of turbulence intensity. This is turbulence intensity, which is given by the ratio of standard deviation of fluctuating component of wind to the average wind speed, U bar. This turbulence intensity can be given for the in all the three wind directions, U, V, and Z. Next are the effect of wind on high-rise buildings, or rather, there are two different types of analysis possible for to measure the effects of wind. One is the static analysis or static effect, and another one is the dynamic effect. In the static effect, we are not concerned with the vibrations produced by the winds in the buildings. So our only concern in the static effect is the calculation of maximum load that the structure will experience during its lifetime. And for this purpose, structural properties such as size, stiffness, and damping are not taken into account. However, in case of dynamic effect, we calculate the along wind vibrations and across wind vibrations. Along wind vibrations are vibrations that take place in the direction of wind, and across wind which take place in the direction perpendicular to the wind. So these parameters of size, stiffness, and damping are important. Next are the cladding damages caused by the wind due to the buildings. So Williams and Karim identified three main reasons of cladding damages: wind pressures exceeding design values, impact from wind-borne debris, and performance of the glass. So the reason why this wind pressure exceed design values is because due to the close proximity of building, local channelization occurs, due to which wind speeds exceed design values, and consequently the surface pressures also exceed design values and cause the cladding damages. These are some of the notable, or rather the cladding damages given in the paper of Williams and Karim. Next is the aerodynamic modifications to counter the wind effects. So aerodynamic modifications are a form of mitigation strategy to reduce the wind load. They fall into the category of passive mitigation strategy. These are of two types: major aerodynamic modifications and minor aerodynamic modifications. In major aerodynamic modifications, we vary the cross section of the building along the height, as seen in these photographs. In minor aerodynamic modifications, we only modify the corners of the building. So major aerodynamic modifications are largely associated with the breaking the coherence of vortex shedding. So as you can see in the case of simple square building, these vortices are shedding coherently along the height, as a result of which they produce across wind vibrations. But these aerodynamic modifications break the coherency of these vortices. And what minor modifications do is that they promote the reattachment of the shear layer, which is separating at the sides of the building. So this also helps in reducing the vibrations caused due to the wind. These are three buildings which employ major modifications in the geometry. Burj Khalifa, which employs setback. This is the Transamerica Pyramid, which is based on tapered design. And this is, as shown before, turning torso, helical design. These are two buildings which employ minor modifications in their geometry. First one is the Yokohama building with the chamfered corners. Other one is the Taipei 101. Now we come to the literature review. So first paper is by Tominaga et al. In this paper, the author presented by guidelines for the use of CFD for the pedestrian wind study. So author presented several guidelines in this paper, from the optimum size of the domain to the type of meshing that should be used, to the turbulence model that should be used. So these are some of the important findings or important guidelines that they provided. A minimum of 10 grids should be used on the building side. Stretching ratio or growth rate should be less than 1.3. Tetrahedron shell should be used along with prismatic cells, and standard K-epsilon model should be avoided. The next is an experimental paper by Tanaka et al., which is also my base paper for this study. So this was an experimental paper in which the authors first conducted wind tunnel experiments of 7 different groups of models. The first group of those models consisted of conventional shaped buildings, for example, square, circular, etc. Rest of the groups consisted of aerodynamically modified models. So first they carried out force measurements on these models, and after the force measurements, they carried out pressure measurements on the 8 models out of those 7 groups of models. So their findings were that setback and 4 tapered model showed minimum along wind overturning moment, whereas square model showed maximum. It was also concluded that multiple modifications give better aerodynamic configuration than single modification. This next one is also a review paper, review cum research paper, in which the author first presented, The author first presented the theoretical information about the boundary layers, the type of wall treatment that should be used. Accordingly, the Y plus value which should be assumed as per the wall treatment we are intending to provide for our meshing, appropriate near wall treatment, etc. Next one is the review, again the review paper by Mittal et al. In the authors comprehensively discussed about 2 mitigation strategies, active and passive. And they also noted that while minor modifications narrow the wake width, major modifications break the coherency of vortex shedding. This next paper by Baraghi and Dalui is a research paper. In this paper, the authors compared a single-sided setback building and a double-sided setback building. The setback was, both the buildings had same base plan area and same height. The setback that was provided in single-sided setback building, it was distributed on 2 different setbacks provided on windward and leeward side in double-sided setback building, and the area was also distributed in both these setbacks. So they compared the aerodynamic modifications of these two buildings and observed that at a particular wind incidence angle of 150 degree, single-sided setback building had very high suction pressure on one of the side faces, while the double-sided setback building did not. And this difference was attributed to the presence of second setback or the levered setback in double-sided setback. Top roof of single-sided setback also found to have more suction pressure compared to double-sided setback at 150 degree angle. However, the drag lift and torsional moments increased from SSB to DSB at particular angles. And finally, they concluded that two-sided setback was more vulnerable than single-sided setback. This next paper by Rajasekhara Babu et al. Is an experimental CFD paper in which the author carried out the CFD study of a setback building having setback at 4 levels at 0 degree and 90 degree. And the authors presented how in this paper, how does the pressure varies along the perimeter of the setback building at 4 different decks that they chose in the setback building. And they also provided a comprehensive information of the wake region that forms behind the building. Next is a review paper again. So in this paper is similar to the paper by Mittal et al. They provided active and various kinds of mitigation strategies, etc. This next one is a research paper by Bailagi and Dalui, in which they compared they carried out a pedestrian wind study of multiple different kinds of setback buildings. For example, single-sided setback, double-sided setback, single-sided, single-sided, double setback, etc. So initially, the authors proceeded with the validation study. Out of their validation study, they concluded that RNG-K epsilon turbulence model best captured the flow separation among the 4 turbulence models that they selected. And in terms of the results that 4 buildings gave, they concluded that double setback building reduced 28 to 30% velocity in front of the building and 68 to 70% velocity behind the building. Next is the problem formulation. So problem formulation is in 2 types. Need for study divided into 2 different sections. First one is the need for study. Second one is the objective of the study. So the need for study is because as the heights of the buildings grow taller, the winds are likely to cause cladding damages to the buildings. So to avoid this, we need to carry out a pressure study or wind load study on the high-rise buildings to determine the critical wind orientation and pressure points on buildings facade where large pressure coefficient values can occur. Changes in mean pressure coefficient values on the 4 faces of a single-sided setback building, and I compared it to a basic square building. This study is helpful in determining the critical wind incidence angle from the point of view of wind resistant design. And in my study, I varied the wind incidence angle from 0 to 90 degree at every 30 degrees interval. So this is the methodology of the computational fluid dynamics. Next one is the modeling, which is the first step of CFD process. So these 2 models I chose for my study. These are the wind incidence angles. I varied at every 30 degree intervals. The scale of these models given in experimental paper were 1/1000. So in the CFD also they were modeled at 1/1000. The lateral dimensions are 50 by 50 and height is 400 millimeters. The setback that has been provided in single-sided setback building is 10% of this lateral dimension. So it is of 5 millimeters. This is my computational domain, which I adopted on the recommendation of Frank et al. So these are the dimensions of the domain. Next is the grid discretization or meshing. So grid discretization means decomposing the domain into smaller subdomains, which are also known as control volumes. And the reason why we do this discretization is because in finite volume method, the information of the flow parameters, for example, velocity, pressure, etc., is stored as at the cell center of each control volume. And as each proceeding iteration runs, these values get updated. So this is why grid discretization is necessary. So for my study, I adopted hexahedral mesh based on the recommendations of Frank et al. ICM CFD mesher was used for meshing. Growth rate of elements was kept at 1.15 from the building walls towards the domain walls, which would be less than 1.3. And the first cell height that I calculated was 0.7 millimeters. These are the governing equations used in the study. These 3 equations are Navier-Stokes equations. This is the continuity equation, and these 3 are momentum equations. When we apply time averaging to these equations, we obtain Reynolds average Navier-Stokes equations time averaging, and also this decomposition of instantaneous velocity and pressure into mean and fluctuating components. When we substitute these in these equations, we obtain Reynolds average Navier-Stokes equation. These additional terms that we obtain are known as Reynolds stresses. In order to resolve these Reynolds stresses, we make use of Boussinesq eddy viscosity hypothesis, which relates these Reynolds stresses to eddy viscosity. So finally, they simplify to this. Next are the boundary conditions. The boundary conditions represent the influence of surroundings that have been cut off from the computational domain. These were my boundary conditions. Inlet was specified as velocity inlet. Outlet was specified as pressure outlet with 0 Pascal relative pressure. Side walls and top wall of the domain was specified as free slip. Domain bottom or ground was specified as no slip. Building walls were specified as no slip. These are the power law velocity profile and turbulence intensity profiles that I provided for my simulation. These are based on the recommendations of Tominaga et al., which are based on the AIG, a Japanese code, basically AIG 2015. So this UZ is the velocity calculated at any height Z, and UZ0 is velocity calculated at the reference height of Z0, which is given in this experimental paper as 11.8 meters at the time of pressure measurement. Alpha is a parameter which depends on the terrain category. As per the AIG code, the terrain category was 4, so the value of alpha was 0.27, and this is the power law turbulence intensity profile. These were my solver settings. Steady state simulation was carried out. The model that I chose was realizable K epsilon model. Wall function that I adopted was scalable wall function. So the assumed Y plus value was 35. Simple pressure velocity coupling scheme was used. Residuals. The convergence criteria was set to 10 raised to the power minus 4, and number of iterations that I ran was 1000. The results and discussion are presented in 2 parts: validation study and parametric study. So first, the definition of mean pressure coefficient, which is given by P minus P naught upon half rho V square. So whenever I will further make use of the mean pressure coefficient in my further slides, it will refer to this formula, where P is the pressure calculated at a particular point on the building surface. P naught is the reference pressure, which is the atmospheric pressure, and half rho V square, where V is the velocity of free stream velocity. So I proceeded initially with the validation study. So I validated the velocity profile at the inlet of my domain to the experimental velocity profile of Tanaka et al. And the results were in good agreement with each other. Next, I validated the pressure contours obtained in CFD with the experimental pressure contours of Tanaka et al. So these results are also in good agreement. Then I proceeded with the parametric study. In my parametric study, I drew center lines on the 4 vertical center lines on the 4 faces of the square building. 1 second. These vertical center lines on 4 faces of square building and 4 faces of this setback building. The center line that was drawn on the setback building, it wasn't drawn on this recession left by the setback. It was only drawn on the faces. And I then compared the mean pressure coefficients in between the faces of both these buildings. So these are the results, and I noted the pressure coefficient values at every 50 millimeters along the height, except at the top height, where I measured the pressure coefficient value at 10 millimeter less than the top height, because in the experimental paper, the pressure taps that were provided, they were provided 50 millimeters above the bottom and 10 millimeters below the top height. So accordingly, I measured the pressure coefficients. These are the graphs, or the comparative graphs, of both the single-sided setback and square. So as at all the 4 angles. So as you can see, the variation between the square and setback is not much, and the reason why the possible reason why there isn't much variation is because the setback that I adopted for the study was only 10% of the lateral dimension. So the less width of the setback may be the reason why results weren't as pronounced as desired. However, at 200 millimeters height, where the setback has been provided in single-sided setback building, a kink can be observed. So at this height, the maximum percentage change in mean pressure coefficient, CP refers to mean pressure coefficient, value of single-sided setback over square was observed at the angle of 90 degree, where it registered a 5.28% increment over square, or in other words, its suction decreased at this height. this decrease in suction may be due to high turbulence generated at the setback roof. I mean, 5.28% is not much value, but as compared to the other faces, as compared to the other angles, 0 degree, 30 degree, and 60 degree, 5.28% was the maximum at 90 degrees. So these are the individual results for each faces. So when wind incidence angle changes from this is the 0 degree angle. So phase A faces wind at 0 degree angle, and wind incidence angle changes like this. So phase D faces the wind at 90 degree angle. So as angle changes from 0 to 90 degree, this phase A pressure coefficient values become negative, which is obvious because the phase changes from being a windward phase to a sideward phase. However, an important observation was made at 60 degree wind incidence angle on this phase, that both the square and setback models showed near zero centerline CP values. At phase A at 60 degree angle, near zero centerline values were obtained for both the buildings. For phase B, they gradually become less negative because at 0 degree angle, phase B is a sideward phase. At 0 degree angle, the phase B is a sideward phase, but when the wind incidence angle becomes 90 degree, it becomes a leeward phase. So the negative pressure coefficient values are always greater on sideward phase as compared to the leeward phase. The least negative CP value for both the buildings were observed at wind incidence angle of 30 degree in case of this phase. Phase C, CP values become more negative because this phase C changes from being a leeward phase to sideward phase as wind incidence angle changes from 0 to 90. And maximum suction or maximum negative pressure coefficient for this phase were observed at wind incidence angle of 60 degree in both the models. Phase D, maximum suction for both the models is observed at 0 degrees. Maximum positive CP was observed at 90 degrees. For both the models again showed just like the phase A at 30 degrees. Just like the phase A at 60 degrees, at the phase D, both the models showed negative zero centerline, both the models showed near zero centerline CP values at wind incidence angle of 30 degrees. So overall, the maximum suction or maximum negative CP value for both the models was observed at wind incidence angle of 30 degrees for phase C at the height of 390 millimeters. And phase B observed maximum percentage changes between centerline values of square and setback, even though these percentage changes were greater in the case when the near zero centerline pressure coefficient values were observed, but these values were much higher in those cases. So for the simple reason that when we calculate the percentage, the bottom value is very small, so the percentage value comes out to be very large, and those values were avoided. For the angle of phase B, observed maximum percentage changes between centerline values of square and setback, and for the angle of 30 degree, the setback recorded a maximum decrease in suction at this angle over the square model of 23.61% at the height of 150 millimeters, which is nearby the height where the setback was provided. So these are the conclusions. The maximum difference between the mean pressure coefficient of square and setback models for phase A at the height where setback is provided was observed at 90 degree wind incidence angle, where the setback building observed a decrement in suction of 5.28%. Then maximum positive CP values observed by setback model was on phase D at 90 degree. At 60 degree wind incidence angle, both the models, again, as I discussed earlier, near zero centerline pressure coefficient values for phase A, whereas for 30 degree, they observed near zero centerline pressure coefficient values for phase D. Maximum suction was observed for both square and setback models, approximately at 390 millimeter height on phase C for 60 degree wind incidence angle. And the maximum percentage change was observed for phase D at 30 degree wind incidence angle at the height of 150 millimeters. Thank you.
Hello.
Yes, sir. Yes, sir.
Yeah. Nice presentation, man. It's wonderful to see some governing equations in the presentation.
Thank you.
So just
Thank you, sir.
a few things like you would have seen some tall story buildings. So when we consider the wind effect in tall story buildings, how will you consider the combined action of wind and seismic force? Can you hear me? Can you hear me? Hello? Can you hear me? Am I audible?
Yes, please proceed.
No, just I asked some question. So the presenter
Actually, I
is,
think he's facing. Now he's here. Yeah, please
Yeah.
proceed.
Extremely sorry, sir. Mistakenly happened.
yeah, tell me. How will you consider the combined action of seismic as well as wind for tall story buildings? No, you are audible.
Sir, I did not consider any seismic analysis. The analysis only pertained to the wind, the effect of wind to measure the aerodynamic coefficients on the surfaces of the building.
No, that's fine. I do accept that. But my only it's a general question. Like when you go for a tall story building, the effect will be combined as well as wind as well as earthquake.
Okay, sir.
Then how will you consider that? It's what my question is.
Sir, I mean, I haven't read about it because so far I did not require it. But in the IS code, I have read about when the combined action of dead load, live load, and wind action is considered.
Okay, fine. Yeah, the another question is like when you have a facade work in tall story buildings.
Yes, sir.
With reference to the facade work, the aerodynamic forces will change, right?
Sir, aerodynamic. Yes, I mean.
With reference to the facade type of work, for example, if you have a glasses or if I have a diagonal truss members as a facade work, aerodynamic forces will change, right?
Yes, sir.
Yeah. In that case, then how will you encounter that? For example, the internal structure is different and external structure facade work is different. And when the entire facade work is going to take care about all the aerodynamic forces, then how will you encounter those things?
Well, sir, if we are discussing about the codal method of calculating the forces, then IS wind code mentions two different methods of calculating the forces. Either we can calculate the measure on the structure as a whole, so which is given by the drag force and lift force, or we can calculate the forces on individual components, for example, beams, columns, etc. Similarly, the claddings of the buildings. So this is known as pressure coefficient method. Separately, the forces on individual components are calculated.
So there is no need to consider the whole effect.
The whole effect is considered when we are when we want to find out the drag force and lift force.
Okay, fine. That's good.
Thank you, sir.
Is my screen visible, sir?
Yes, it is visible.
So good evening to all of you. Today I am going to present my topic on the comparison of analysis of high-rise structure with the diagonal lateral load resistance system with the composite membrane and the base isolation. These are the contents of my slides. Firstly, talking about there are the three parameters, three keywords in my study: the diagram members, the composite sections, and the base isolation. Firstly, the diagram structure is nothing but it's a system in which the vertical column has been eliminated at the periphery of the building, and only the diagonal members are provided in the periphery of the structure. or in the interior, the vertical column may be there or not. In our study, we are focusing on using the composite members and the base isolation techniques with the diagonal structural members. The composite sections has been used because of their high strength, high ductility, and the large energy absorption capacities. Now, talking about the base isolation, it is a technique by which we can uncouple our structure from the effect of the ground motion. That's why the disturbance caused to the ground, caused by the ground motion to the structures is eliminated or reduced by reducing the natural frequency of the motion. Talking about the literature review, the first two papers representing the literature review on the diagonal structural member, and in the diagram they have find out that the diagonal structural system in a building construction on high-rise structures performs better during the later loadings, and all the later loadings has been resisted by the diagonal members, and the internal column has only to be designed for the vertical columns, vertical loadings only. Then the Sharma et al. In 2016 has find out that when we are using the composite structures, then the interstory drift and the displacements has been increased than the RCC structure. Similarly, Tara and Bhavna Ryan 2020 find out that for the low-rise construction, there is no need to use the composite sections in the buildings, and the normal conventional buildings are more suitable to be used. Similarly, in the, Rajan and Abraham in 2020 find out that the CFST sections are more suitable to be used in the buildings with the mass irregularities. Next, the last two papers I have considered for the diagrams base isolation model. The base isolation, after doing the study on the base isolation model, they have find out that the base isolation is helpful in reducing the base shear and the story shear in the structure, and they can control the story displacement also. After doing the literature review, the problem is formulated as, although the diagonal structural systems is very much effective in resisting the loadings, but as the height of the structure increases, the effect of loading like earthquake and wind becomes predominant. So there is a need to further improve such kind of structural systems, and the two different techniques, composite sections and a base isolations, has been considered to be used in this study to improve the diagonal structural system in the high-rise construction. The objective of the studies were to get a seismic response of a diagonal structural system with or without the base isolation technique and the composite sections. And the main idea is to check the effectiveness of the base isolation and composite sections in the high-rise structure using the diagonal structural system. This is the plan and the elevation considered for the structure. You can see here in the elevation, the diagram is provided at each story level and the diagonal with the diagonal members, and in the plan you can see the interior columns are provided and that are only verticals, and there is no diagonal members that is provided inside the column inside the building. In the elevation, base isolator is also shown at the base of the structure. In the methodology, a G+10 structure is 10-story structure is considered with each story height as a 3 meters, and a dynamic analysis has been performed using the response spectrum analysis, and composite members and the base isolation has been used. 4 models has been considered for the analysis. The first model is used with ordinary diagonal structural member without any composite and base isolation technique. In the second model, the diagonal structural model is used with the composite sections. In the third model, the diagonal structural model is used with the base isolation, and the fourth model is a combination of model M2 and M3 in which both the composite section and base isolation has been used. After doing the dynamic analysis, the comparison of the results in terms of base shear, time period, displacement, story drift, and story shear has been performed for all the 4 models. These are the results and discussion for the maximum story displacement. The plot has been shown. The red line is shown for the M1 and green line is shown for the M4. It can be seen that the M4 model shows a higher amount of reduction of the story displacement, and it results in approximately 72.5% of reduction in the displacement than the M1 model. Similarly, in the story drift, M4 shows a 76.5% reduction in the maximum story drift values. In the case of the maximum story shear, the model M2 shows a higher values than the M1, and M4 shows a little bit higher values than the M3. It is due to the fact of the composite columns or composite sections included in place of the diagrid section. The model M2 results in 90% increase in the maximum story shear than the model M1. Similarly, in the case of base shear, the model M2 shows the higher amount of base shear, and model M3 and M4 shows the very less base shear than as compared to the M1, and it results in approximately 66 to 67% reduction in the base shear because of base isolation technique used in these two models. In the fundamental time period, the behavior becomes opposite than the base shear. Now the M3 and M4 results in the higher amount of the higher amount of time period than M1 and M2, and M2 shows 14% less fundamental time period than the M1 model. And M3 and M4 result in approximately 200% more fundamental time period than the model M1. Conclusion, it has been seen that while using the composite sections, as it provides a more stiffness to the structures of a diagrid structural system and increasing the self weight of the structure, it results in the decrease in the displacement and the drift values of the structure. Also, because as it adds in the seismic weight of the structure, the story shear and base shear, which is a function of seismic weight, also goes on increasing. But while we are talking about the base isolation is a system which uncouples the structure from the ground motion or the ground vibrations. That's why the force that are going to transfer above the structure reduces. That's why the story shear and the base shear goes on decreasing, which results in reduced displacement and the story drift values. As I already told, the composite members provides more rigidity, and because of this, the frequency of motion of the structure increases and fundamental time period of the structure reduced. But in the case of base isolation, it provides a more flexibility at the base of the structure. So the fundamental time period in this case increases. Including the composite section, the diagram member provide a stiffness to the structure and can control the overall displacement, but at the same time it can increase the base shear and reduce the fundamental time period of the structure, and which may be dangerous for the structure, as reducing the fundamental time period result in increase in the frequency of motion, and structure may suffer much or more in the lateral loading. So the problem can be mitigated by using the base isolation technique, which can result in the higher amount of the fundamental time period and can reduce the base isolation. These are the references. So thank you.
It's very nice presentation. Just I have a couple of questions.
Yes.
Up to what story level you are preferring or you are suggesting base isolation?
Sir, actually, this study is conducted to find out this thing also, because I have seen very much reduction in the story displacement value and the base shear, and we can further provide our base isolation technique more than 15 story structure. And also the composite structure, I do not prefer to be used more than 10 to 15 story structure, because as we are using such kind of additions, it may result in a more rigidity to the structure, which may be in a dangerous in the earthquake or lateral loading.
Actually, you are giving some inverse answers to me. Base isolation is not limited; it's a limited one. We can't go for a very tall building because of higher modes. And the composite can be go for higher structure. If you go for any tall story buildings in the world, it is probably, it would have been constructed using the composite building methods, like combination of RCC plus steel. Okay, so you are giving me the reverse answer. But the base isolation is not recommended for tall story buildings because of number of modes considered. So the answer is base isolation is only for short story buildings, not for tall story buildings. Okay.
Okay, sir. Okay, sir.
Okay. Thank you.
Thank you, Harpreet Singh. Can please Mr. Abiola present now?
Can I go ahead, please?
Yeah, you are
Okay. So I'll be presenting this paper, evaluating the potential of ion filings in mesering blocks. So basically, it's more of a material paper. Some of the things I'll be discussing within this short time is just a basic introduction, some literature review, and the reason behind this paper and the methods adopted, also the results and discussions. Now, basically, ion filings are waste materials. It's very common in metal workshops. It's usually the byproduct of, scraping of some of those metals. And most times in Nigeria and some other African countries, it's a relatively large, it comes in relatively large amounts. So on the other hand is mainstream block. The mainstream block industry in the sub-Saharan Africa, it's very, very strong. And quite a number of blocks are produced every day and even yearly. But one challenge that we have come to realize is that this industry depends so much on fine aggregates. And most of these fine aggregates are always gotten from dredging and from rivers. And most times the action of this industry affects life below the water. So we are actually looking for alternatives to actually reduce the dependence on fine aggregates. So that's the reason behind this. Now, we all know that the use of waste of all kinds is fast becoming the interest of most researchers, as it provides a better alternative to waste disposal. One of the challenges with some of these waste is that they are non-biodegradable. And when they stay too long in our environment, they cause nuisance to the environment. Particularly, then also in the African context, the cost of recycling is very high. We can't afford to go by that. And also environmental pollution, it's a major issue, as pointed out by Meki et al. And also some of these wastes, they are deposited in land, landfills, which occupies a large landmass. So when you combine all this together, you'll see that there is a need for us to use these materials in a much more sustainable approach. And one thing that we have discovered from previous literature is that effort has been made to actually use some of these waste materials. For instance, Davis and Olonofide in 2021 used polyethylene as final grade in sand in blocks. And it was discovered that the density and compressive strengths were above the minimum required by the standards in that particular part of the world. Then also in 2021, Robert et al. Also did the same thing, but this time around using coconut husk as final grades in blocks. And also they reported that though the blocks were not above the minimum, but they could serve as non-load bearing wall in construction process. In 2018, a similar effort was made by Akin Yele and et al. And also they gave an impressive result that this material, crushed waste plastic, which is readily abundant, it's also could also be used as fine aggregates. So when you look at some of these events that have passed, that actually what helped us to develop a problem formulation for this study. The first thing is to source for a waste material, then look at its availability, how available it is within our context and an environment. Now, if it is available, now can this be used as an alternative for fine aggregates? So then to do that, we need to evaluate the engineering properties. And on the other hand is the economic aspect of what we are saying. If this thing is available, but if it is not economical, then it has no supply chain, as it were. So this actually formed the problem formulation for this concept. So in trying to do that, this is the methodology that was adopted. Portland limestone cement, fine aggregates, river sand, and stone dust. In Nigeria and some other African countries, it's usually a practice to mix some of these materials. So what we do was just to basically model what is obtainable in the market so that we can get a true representation of what it is like. So in this case, what we did was to replace iron filings at different percentages, up to 20%, and to study some of the properties that we think are of importance, especially to the end user. So the first thing was to characterize the sizes of these aggregates. Then when we characterized the sizes, we discovered that the sizes were quite in consonant with some of those of standard fine aggregates. And it even performed better than one of the particular aggregates that is common in our immediate environment, which is stone dust. So then we also discovered that it was also discovered that the aggregates were, they were based on the classification, river sand and iron filings had values greater than 4.0, that's the CU, and this shows that they were well graded. In a previous research by Adekunle et al. 2018, it was reported that well-graded fine aggregates increase the bonding strength of concrete blocks whenever they are used. The next thing was to ascertain the rates of absorption of water when these iron filings was incorporated into the blocks. Now, it was discovered that at the very early stage of exposure to water, the samples with iron filings had a lower absorption rate than the control samples, which was relatively good when we look at it from the aspects of capillary suction of water. Most times for blocks, they tend to absorb water so fast because of the pores within the structure. But in this case, when the iron filings was incorporated, the rate of absorption was reduced. However, one major concern that was observed is that if one were to use this in practice, what about the issue of rusting? Because these iron filings are from iron, and we all understand what happens when iron comes in contact with water. So the next thing was to ascertain the compressive strength, and it was also observed that at 7 days of curing, the compressive strength was relatively good, and it became better as the days of curing increased. But one thing that was so clear is that some of the materials, especially the ones with 10% and 15% of iron filings, they were not as good as the control. However, the iron filings with 5% was quite reasonably good, and it was a little bit above the minimum requirement by the local regulation in Nigeria, which was 2.0 Newton per mm square, at least for non-load bearing walls. So the next thing was to ascertain the cost, the cost implication. If you are to incorporate this in 100 units of blocks, what are you going to get? So from this, it was discovered that even though there was a price reduction as the content of iron filings increased, two things were observed from this. The first one is that the sand didn't really have much effect on the economic value as compared to the cement. But if it was incorporated at 5%, we can still have about 1.05% reduction in price, which is a bit low. But when you are to consider a project in a large scale, it might be a very good complement, as it were. So that leads us to some of the conclusions that we made in this study. Is that the first one is that the particle size of the ion filings actually compares favorably with those of conventional aggregates. And also, as the percentage of these ion filings increased, the subtlety reduced, which is good. But on the other hand, is that it could be prone to rusting. And presently, an effort is being made to see if we can coat these ion filings with polyethylene, coat it with it, and see if we can reuse as an aggregate. Also, the compressive strength also were not so bad, and 5% and 10% can still be recommended, going by the standards in the local environment. Then on the part of the cost analysis is that at least at 5% addition of ion filings and at 10% addition of ion filings, there could be a reduction in costs of about 1.05% to 2.10%, which is good, especially when you try to look at the project on a large scale where you have a lot of blocks being used. It's going to be a very good one for those who are using it. So these are some of the references that was actually sought and were actually considered in this study. Thank you very much.
Yeah, excellent presentation, Mr. Adebanjo. You have explained all the things very wonderfully. So one question from my side, have you compared what would be the economical impact if you use the iron dust as a replacement to fine aggregate? To how much % we can go for the saving?
Please, can you repeat that again? My network is breaking. Hello?
Am I audible now? Am I audible now?
Yes, much better, much better.
Yeah. So have you done any economical analysis if you are using the iron dust by replacing the fine aggregate?
Okay, you mean which dust?
Iron dust you have used as a replacement of fine aggregate?
Yeah, in this study, what we did was to evaluate that of ion filings.
Okay.
And what we discovered is that on the part of cost analysis, there was a slight reduction. However, on the economic part, I don't think we have considered that, but I think it's something that is noteworthy, which will be very good.
Okay. Okay, thank you, Mr. Adebanjo.
Thank you.
Yeah. Now we can move to the other participants for their presentation.
Okay, Mr. Rajesh, are you present?
Yes, ma'am, I am present. My paper ID is given.
Yeah, so you can continue with your presentation.
Okay.
And kindly switch on your camera also.
Yeah, sure. Is it visible, ma'am?
No, not yet.
Is it? Hello. Madam, is it visible?
No, not yet.
Just a second.
Again, you try to share the screen.
Yeah, I'm trying to share the screen, maybe. Can you help me out from where I have to share the screen?
Just beside the number of participants, there is one
Yeah.
arrow, and below that it is written share screen. So
Okay.
click at that arrow and you'd be able to share.
Madam,
Have you logged in through your laptop?
I'm trying to connect via my mobile.
That is the problem. You try to get connected with your laptop.
Okay, just give me 1 minute, ma'am. Please.
Yeah, okay.
Ma'am, there is a option showing launch meeting, and when I clicking the launch meeting, there is nothing happen.
Okay, just below launch meeting, there's one option, join from the browser.
G. Yes, ma'am.
Yeah.
I requested for joining meeting. Is it audible?
Yes, it is audible, but since you have logged into two devices, you just
Yeah,
toggle
yeah,
from your mobile.
yeah.
And now share your screen. Yeah, your screen is visible. Please proceed. Yes, Mr. Rajesh Kumar, you can continue. You are muted. Unmute yourself. Unmute yourself. You are muted.
Is it audible, ma'am?
Now it's audible. You keep your presentation in the slideshow mode.
Yeah.
Yeah. And start from the first slide.
Good afternoon, everyone. My name is Rajesh, and I'm presenting my paper on recent developments in affordable high-rise buildings, a case study. There is content like introduction, recent developments, a case study, resultant discussion, conclusion, and references. Introduction. The development towards imperishable is a serious issue since from the last few years as the construction sector, especially building construction, create a portion of the yearly surrounding deterioration. As high-rise buildings demand is increasing nowadays in our surroundings, especially in NCR areas, enhancing the consumption of more raw materials, energy and resources, which are directly accountable for increasing hazardous content in environment and which are also dangerous to occupant health and surroundings. The high-rise building construction industry is a key factor of any financial system, but has a noteworthy unfavorable influence also on the surroundings. That is more.
Yeah, sorry to interrupt. Please keep it in slideshow mode.
The essential for sustainable development building construction, the construct a building imperishable starts at the planning stage. A high-rise building should be pinpointed in a centralized place so that occupant can use the public transportations or public amenities and less or non-renewable energy run vehicles. Also, energy discharge should be optimum. Utilization of water should be zero. All wastewater should be treated biologically and recycled. Renewable energy also important factor to use by the occupants. Recycled substances should be used as a greater extent as maximum as can. As an alternative of bricks, aerated concrete blocks or fly ash bricks can also be used for better insulation and heat declining. Roof insulation should be done with clay rather than chemicals. There are some recent sustainable technology which was shortlisted and selected by the GSTC. It's Global Housing Technical Challenge India, an initiative by Ministry of Housing Urban Affairs. That is precast concrete construction system, 3D precast volumetric. Second one is precast concrete construction system. Third one is light gauge steel structure system and pre-engineering steel structure system. Fourth one is prefabricated sandwich panel system. Fifth one is monolithic concrete construction system. And sixth one is stay in place formwork system. There are 6 lighthouse projects which were started by the government of India in 6 different locations in our country. The first one is situated in Indore, Madhya Pradesh. The technology used in that project is prefabricated sandwich panel system, and the number of houses is 1024 houses were constructed in a record time of 12 months. The second one is Rajkot, Gujarat. The technology used in monolithic concrete construction using tunnel formwork. The third one is situated in Chennai, Tamil Nadu. This project is also completed in record 12 months times during COVID pandemic. The technology of precast concrete construction system and precast component assembled at site was used in that project. Fourth one is situated in Ranchi, Jharkhand. In this project, precast concrete construction system that is 3D volumetric 3D system. And fifth one is situated in Agartala, Tripura, and there were light gauge steel structural system and pre-engineered steel structural system were used. And the last one is situated in Lucknow, Uttar Pradesh, and there PVC stay in place formwork system technology were using. As far as the concern of my case study, the project is of lighthouse project for Ministry of Housing and Urban Affairs, by Government of India, Location is Nukumampal Road, Chennai, Tamil Nadu, and the construction agency for the project, for the particular project, is Messrs. BG Sri Construction Technology Private Limited. The duration of project is of 12 months, and the total plot area is 29,222 square meters. The carpet area for each flat or unit, that is 26.7 square meters. For total built-up area was 43,439 square meters, and the technology used is precast concrete construction system. There were 1,152 flats which was constructed and under G+5 high-rise story buildings. The broad specification is as under the foundation. In foundation, we use RCC isolated footings, and RCC precast beam columns were used as structural frame. The floor and slab roofing, we used RCC precast slab. Building under study are G+5 constructed as per GSTC Global Housing Technology Challenge India for sustainable development in affordable housing by using 3S prefab technology. 3S system incorporates precast dense reinforcements, neat concrete hollow core columns, structural RCC shear walls, beam, stairs, solid precast. Structural continuity and robustness is achieved through wet joining using dowel bar continuity reinforcement placed at connection and joining at various structural framing components. These are some pictures, or you can see the precast RCC shear walls, also precast RCC column, core concreted using self-compacting concrete is also a renewable, innovative technology nowadays using in aluminum shutting formwork for speedy construction and repeated cycles, and the viability of the shuttering components also. 3S precast RCC beam, you can see the top part concreted using SCC concrete. And then you can see precast rebar lattice girder composite slab having reinforcement concrete topping. Now you can see the precast slab component assembly, how the components are assembled at site, and the building after assembly of all precast concrete construction systems. After studying the detailed plan and procedure, determining the resources required, scheduling the activities, and preparing the approximate estimation.
Sorry for the interruption. Your PPT is not moving, man. It's still in introduction slide.
Sir, but here I'm moving, and my screen, all the slides are moving.
Okay, Mr. Rajesh, what you do? You unshare and again share your screen.
Stop sharing.
You just stop sharing and again share the screen.
Okay. Okay. Is it visible?
Yeah, it's visible. Keep it in slideshow mode.
Okay, ma'am.
Just at the bottom, you click at slideshow.
Yeah, is it visible now?
No, it's not slideshow mode now. It's
Use
only
Shift
normal
F5.
mode.
Whenever it is, no, that's
Okay, let him.
It is visible, sir.
I think,
It
sir,
is
keep
visible,
it
but not in
normal
slideshow
mode.
mode. Okay, you can go ahead. Go ahead.
Okay. This slide is you can show, sir, the assembly components at site for precast slabs, and this is after the assembly of all precast concrete construction system components. The complete after studying detailed plan and procedure, determining the resources required, scheduling the activities, and preparing the approximate estimation, and comparing one of the techniques from above mentioned, that is conventional formwork technique with respect to aluminum formwork technique, and precast concrete construction system and conventional construction system. There is some comparison, the reinforcement saving, about brick requirement, wall paneling, slab roof, time saving, initial investment, feasibility, labor cost, stability of high rise, environmental concern, homework required. The conclusion is 3S prefab technology completely eliminates the use of timber and forest procedure of any category. On the contrary, use of fly ash and GGBS enhances the sustainability, the thermal and acoustic insulation provided by the AAC block masonry facilities, reduction in energy towards maintaining comfort level temperature within enclosed habitat space. Also, considerable reduction in dead load is achieved due to the use of foam finish precast components and AC material, resulting into the better performance under seismic load. All the structural components are pre-engineered and manufactured in factories with objective quality control, resulting into dimensional accuracy, correcting and spacing of reinforcement, uniform protective cover, assurance on design strength due to use of design mixed concrete, having minimal water cement ratio, which ultimately results into durable structure. These are the references. Thank you.
Hello.
Yes, sir.
So do you know how to design a precast structure?
Sorry, sir.
Do you know how to design a precast building? So what is the difference between the RCC building design and precast building design?
So the precast component, all the precast components were casted in factories.
No. Understand my question. I'm not talking about that. I'm just asking what is the design philosophy and what is the difference between the design philosophy of RCC and precast design? I know all the elements are cast at factory level and being transported to site level and then executed to connect together. That's fine.
Right.
Question is, what is the design philosophy difference between RCC and precast? Just giving a random review is not worthful. So you should know what is what.
Yes, sir.
Okay.
Yes,
fine.
Sir. Thank you.
Rajesh,
Yes, sir.
have you visited this sites?
Sir, I'm going tomorrow for the site. Actually, the Urban Housing Conclave is organized.
On field, how many sites you have visited before doing this review?
The two sites. And third one is tomorrow.
Thank you.
Do you know modular construction technique?
Sir, I'm using the box frame technology, sir.
Do you know modular kitchen?
Yes, sir.
What it exactly?
There are some modular frame components, sir, which are casted and erected in place, concerned place, particular area.
Which comes under standard size?
Sir, they can be customized, sir, not standard, sir. As per the design requirement.
Modular kitchen, modular stands for the standardized systems. So in case of precast industry, standardization is important.
Yes, sir.
Okay, and have you taken any feedback from those who, if anyone has occupied that buildings, prefabricated buildings?
Sir, actually the occupancy in these buildings are not started yet. They are going to hand over the projects within this month.
Okay.
Yes, sir.
Okay, thank you.
Thank you, sir.
You already know how to do this thing, you already done.
If no more questions, so can we go then to the next presenter?
Yeah, please proceed. Who is the next one?
Hello, am I audible?
Yes, you are.
Yes. Good afternoon, sir.
I thought it only copies.
Can you see my screen? Hello.
Yes, we can see.
Okay. Good afternoon, sir. Today I am going to give presentation. Sir, one.
Presentation mode.
Okay. Today I am going to give presentation on my research paper, a study on effect of uncertainties on standardizing workflow process in construction firm using SPSS. So for that we have introduction, literature review, problem formulation, methodology, result and discussion, conclusion, and at last references. So for in building projects can be increased by good management techniques. Very few business have implemented formal procedures to control these behaviors. In construction, there is a need to improve standardization, which is impacted by diversity and separation of different construction firms. K. Venkatraman in year 2019 analyzed that 70% of respondents have stated reason for delay is possession of site make an effect on timely completion of project. Contractors who are tired of rectifying typos and looking for lost documents and files, standardization can also help in achieving uniformity in management operations, indirectly lowering the conflict between major stakeholders. According to Lean principle, building procedures is to be more uniform to boost efficiency and eliminate waste. Workflow construction managements can take more set it and forget it approach to the day with configurable automated process that reduce project management and administration so that they can focus on critical aspects of running projects. So for that we have objectives, identifying factors affecting standardization of workflow with literature review and expert advice, to recognize these factors using RII and analyzing these factors using factor analysis in SPSS, and validating is using regression analysis in SPSS. So the scope of the work is to study, determine to accomplish using the following process. Literature review factors were identified. Those factors were verified by industrial experts for framing a questionnaire. RIA is used for ranking factors, and factor analysis is used in SPSS to identify the factors. And at last, we create a model and validate it using regression analysis. Sarah J. G addresses that project experience time delay, cost overrun, and the generation of massive amount of waste. To address these challenges, lean constructions have been introduced in Saudi Arabia construction industries with a structured questionnaire survey of 2 to 82 construction professionals was carried out. By using mean score and ANOVA test, it was found that waiting is the most common type of waste, and the level of implementation of lean construction KSA is still increasing. Gautami Vidya G aims to find the methodology for assessing the present total quality management. For that, critical success factors in implementing total quality management in construction industry and various concepts of quality management affecting quality performance and research methodology was adopted. Fong Patricks and Yep Jing in 2006 stated that various project stages, there is different ways of recording a lesson learned system. Firstly, to evaluate and study were conducted before implementing LSS. Second, training of top management. Third, knowledge master is chosen early to assist the LSS. Nizam Akbar developed a realistic working technique, implementing the SMM and tracking the cost of the task. Working practices, setting administration and tendering cost control objective. To meet this complexity, the need of current and forthcoming project, it is necessary to upgrade new SSM framework for different projects. Kumar Nirja mentioned factor analysis and multi-nominal logistic regression as two methods used successfully in studying identification of crucial factors and success factors and crucial coordination activities. Factor analysis frequently utilized in integrating variables that share the same variance in multiple aspects known as factors and are mostly used for determining profit and loss of factors. Here identified a group of dimensions also known as latents that are not present in large quantity of data or factors. The initial set of variables or factors that can be utilized for regression, correlation, and discriminant analysis. Problem formulation. This study examines the potential for the application of process for managing the workflow within the construction firm. Construction management has integrated into large construction firms, and ability to manage the construction flow intelligently has been and remain a very exclusive goals. At modernization, we constantly hear from contractors who are tired of memorizing details, rectifying typos, and looking for lost documents. So we critically need the industry to incorporate and to adopt the standardization in construction. Standardization continues to support achieving uniformity in management, operation, and indirectly lowering the conflict among major stakeholders. To study the management system of construction industry for determining how contractors are tracking field production. This is our methodology. First, we did literature review, then data collection. The results of RII gives us the top 10 factors which affect the standardization. Then we did factor analysis. The questionnaire was designed using Google form, and we got 112 questionnaire responses. So using that responses, we did the relative important index, and from that we get these 10 factors which are crucial for our research. Hard to plan for an unleveled schedule is the first rank. Lack of production benchmark and standards is the second. No list of resources was third. Insufficient time given to the design team to design the faculty and prepare documents. Demonetization of team members losing their co-worker due to project downsizing. Fragmented supply chain. No use of information system or software packages to support activities. No willing to share among the project participants. No commitment from top managers. To evaluate whether the data is appropriate for analyzing using factor analysis, KMO and Batten test is found out using SPSS. And this was the result of KMO, which was more than 0.7. So the data is suitable for doing factor analysis. Next, we did factor analysis using principal component analysis using Varimax rotation method. So all the 50 factors were used because all 50 factors were having more than 0.5 factor loading. These were the result of PCA. We get 10 components from 50 factors. These are 5 and these are next 5. So we gave them the latent meaning from the literature review and expert advice. So each factors have 4 or 5 components. Sorry, each component have 4 or 5 factors. After identifying these components, these 10 components, we did we make an assumption model. In that, first 1 to 9 factors were taken as independent variable, and the 10th factor was taken as dependent variable, that is final inspection approval. So after doing that, we did a regressional analysis to predict the relation between this independent variable and dependent variable. We used SPSS for doing that. So this was the result we get. For R, it was 0.45, and for R square, it was 0.984, which was sufficient for us to say that the model fits our model is good, and we can proceed and implement it in the further study, or we can implement it on ground. This was the ANOVA result. These two are the results of regressional analysis. This determines how well the model fits, and this determines how significant the model is. These were the result from 112 questionnaires. as we discussed earlier, 10 components. KMO result, which is more than 0.7, which says it is statistically significant and we can use the data. Then we have total variance of 0.79, which is more than 60%. So this we can make a model with these components. So our conclusion is, through literature review and expert advice, we considered for identifying 50 factors affecting the workflow processes, top 10 factors affecting imperative process as shown in the table 2 as previously I said. 10 key factors were identified in using factor analysis, and a model was created which was then validated using regressional analysis, and we got results which says that model is significant and is fit to use for further purpose. These were the references we used. Thank you. Hello.
Yes.
Yes, sir.
Syed,
Yes, sir.
can you tell how we can able to implement this model? This, you have prepared the model, you have done
Yes,
the
sir.
statistical analysis. How we can
Yes, sir.
implement? This is what with respect to particular case-based study.
Yes, sir. We took this questionnaire from the ground what we are working on, like from the 5 or 6 companies which in same locality, because from different localities we get different results. So if we want to implement, like our organization is still developing, so if we want to develop it more, then we have to make a study like this so that we can develop it more and use these components to improve our performance.
So this study is particularly region specific, wherein your model is also fits for the particular region wise, wherein
Yes,
that
sir.
construction is going on.
Yes, sir.
But again, this questionnaire, again, there is a maybe if in your questionnaire the
Sir.
workers are happy or not, if that is the case is there, that also may vary.
Pardon, sir. Can you repeat, please?
Questions.
Yes, sir. Sir, tell me.
With respect to your study, that also
Sir.
varies then.
Sir, different localities have different, like if you are going for a subcontractors in our location, that varies because I worked in Dubai previously, and when I come back to India, the total scenario was different. There the system was different, and here the system is different. So if we want to cope up with the system, then we have to follow the process and procedures what we are doing here.
Okay.
Yes, sir. Sir, any more doubts?
No.
Thank you.
Other members, please.
Yes, I'm sharing my screen.
Now, Ms. Susan, please.
Yeah, I'm
present
waiting
your
for Zoom to respond. Can he unshare the screen, please?
Yes, I'm trying to do that, but I'm not able to find. Yeah, done.
Your screen is still shared. Sorry, or I will close Zoom and start again.
Yeah, participants, please ready as per the sequence that has been posted in the WhatsApp group as well as in the mail. And while presentation, you have to keep switch on your camera.
Till then, Sayyid Minazuddin, please present your presentation.
Yes, sir.
Yeah, Mr. Syed, please proceed.
Yes, ma'am. Ma'am, my presentation is about a study on factors affecting safety of workers in construction projects. The contents are literature review, the contents are introduction. First, I'm starting with the introduction, literature review, problem formulation, methodology, resultant discussion, conclusion, and finally, references. Next, as with the growth of the gross GDP of the country is significantly impacting by the construction industry. There are 33 million of the people were employed, the second largest in the nation when behind the agriculture university. The agriculture behind the agriculture industry. The majority of the workforce are the migrants and untrained. They are hiring from the rural areas. There is no established method that is there for the screening of the on construction side. So accident are cause and the fatal and non-fatal accident are occurring as daily on a daily basis, or we can say the number is very high. And even while the construction industry is significantly improved sector and lagging behind the many other industries in terms of safety. The next, the literature review, and the Elias in 2005 described that the cost benefit analysis. They have done a quantitative method. Quantitative method was used to collect the data. Quantitative method are used to collect the data, and the total 79 contractors sent the questionnaire to the 79 contractor, medium, large, and they have found that the benefits of increasing the safety on site was 3:1 ratio was 3:1. 62% gain, the profit gain, and 38% the loss. The method was potential to improve the decision making process, accident prevention and reduction. And next is CM Tham at 2010-2004 mentioned that the behavior of the contractor, concern with the PPE, provisional production equipment, meetings, regular meetings, and the awareness. They are reduce in input of the sources and safety operation system. The studies also asked the government for the legal enforcement for the training program. And the next, the hazard identification, the safety training. They have conducted using the BM tool to improve the safety performance in construction training. Next, the influential safety factors, the awareness and the success factors collected, and they have done the questionnaire survey, and they have found that the PPE correctly could reduce the risk at construction site. The I have said in 2013, the occurrence, occupational health and safety of the older worker above the age of 55. They have the difficulties in 19% of getting the hear loss and the others. And Mohammed in 2009 provided that the construction organization becoming the more aware the physical aspects, technical hazards, and reducing the accident. These organizations inside development performance and the development using the balance scorecard on site. The top management commitment is more important when we are going for the safety at construction site, because the behavior of the contractor and the other at the top of the management is responsible for most of the accidents that are occurring on site. And the next problem formulation, when we are comparing to other industries, the construction has a higher fatal and non-fatal accidents, although injuries, although the steps have taken in the recent years in the safety, and the many of the literatures have been seen that the researchers are involving in safety, construction management, the major emphasis on accidents, both the financial and the human aspects. When they might improve the profitability and competitiveness of the study. When there will be injuries and the accidents are happening on the sites, the reputation of the company on site, it's reducing. The projects which will in the future are not getting as they can get many. So the reputation of the organization is also reducing. The next methodology, in the methodology, the literature study have conducted, then the data have collected using the various literatures. So after the thorough literature, the analysis is done using SPSS. In SPSS, RIA method is used. RIA. Then the significant test is used. When the significant test is like certified, like given the green signal, then we go for the short list, the factors, most impact factor. Then I have used the fuzzy model in MATLAB. I have created the fuzzy model in MATLAB. Then validation of the model is done, and finally the conclusion. The next, the data collection. Data have been collected and observed in the field. Construction questionnaires play an important role in data collection. The proper design of the questionnaire is important in a high response rate. So the appropriate format has to be followed while designing the questionnaire. And the questionnaire have designed using the 4 parts. Part A of the questionnaire, V, C, D, 4 parts, and there are the different sites visited, the residential building, commercial, and the industrial buildings, heavy civil also. And the response rate was 37 factors have collected from the various sites, and the response of the rank, when firstly I have used the RIA method, RIA, to rank the factors. So I have got the first site supervision play an important role in while we are to reduce the accident on sites. Next, RIA used like for the Likert scale, very low, medium, high, and very high. Next, the factors which I have found in RIA were site supervision. Poor site supervision was the first factor. So the first next was the absence of safety officer. Then the third one, indicate inadequate PPE. Like that, I have found the 10 ranks using RIA, and the ANOVA is used to find out the significance of the factors. Compare the mean of independent groups where the statistical evidence associated with the population. So I have found the 0.0 significant factor significant. So it is applicable. We can use the factors for the study. Next, the fuzzy logic is used. The fuzzy logic is used in MATLAB. So we have used the fuzzy logic because in the fuzzy logic we have like different we can use different like the person who is going to give an answer was not only yes or no. There are the many questions, the answer they will give. So we have used this by using the fuzzy logic. We have created the membership functions in fuzzy logic. Then we have provide the rules in that, the input and the output. Then we provide the rules, fuzzy rules. Next we found the fuzzy results. As the fuzzy results indicates the risk, high risk, medium, low. So high risk was A7, factor number A7 was 0.61, and poor site supervision. Next is second, A7 was high risk. And the next, when we are comparing the results and the fuzzy logic interface, present the outcome of conclusion that the risk value divided into the three categories: high risk, medium, and the low risk. High risk was found the poor site supervision, rank was first. In when we see both the RII and fuzzy, the both values were got first, second, third was same, like poor site supervision, and the second was the absent of safety officer, and the third, inadequate TP was provided. And the conclusion, thorough literature have been carried, and by the expert opinion, the factors have segregated. Management related factor, part A was the management related, and the labor, equipment, material, and technical related factors. The questionnaire responses include the engineer, contractors was used to find the RIA. The top 10 were identified, and they are poor site supervision and so on. The significant test was also done using the ANOVA, and accepted value was achieved, as we have seen in the table 2. The last one, the model have been developed using the fuzzy logic, rule base, and the favorable result obtained. If you are providing the proper, if you are considering all these factors on site, we can reduce the accidents, and we can improve the reputation, and the projects of the company can increase. So these are the references. Thank you.
Thank you, Sayed. So while preparing your fuzzy logic model, you have considered all the factors, or only the factors which are having high dominance?
Sir, I have taken all the factors, sir.
You have considered all the factors?
Yes, sir, all the 34 factors. Firstly, I have done with RII. Then in the phase 1, sir, I have done only 10. Then again, as per the instructions of my guide, I have taken all the 37 factors.
Okay, then in case of your fuzzy logic, 37 factors are there. Within that 37, there are combinations you have made.
Yes, sir. As per rules, sir.
Rules. How many rules you have given?
Nearly 300, I think, sir. Near about 300 rules.
So
like different providing different.
So an average of maybe 3 to 4 questions, or maybe 5 questions per your factor.
Yes, sir.
Okay, and what is the use of your initial results? Whatever you have done the factor analysis, what you have done with that?
Sir, this I have done in case study, sir. I have used in the case study all those factors. I have found they are encountering on sites. So by using these factors, by considering these factors while starting of the site, they can reduce the accidents or injuries which is happening on a daily basis, or on an average, sir.
Okay, so have you validated this model?
Yes, sir. Yes, sir. I have validated using the case study, sir.
So how many case studies you have considered?
three case studies, sir. First is residential building, sir.
Okay, and in order
Second
to
is
okay. In order to prepare
Yes,
this, how many buildings you have taken into consider?
sir, for questionnaire, sir, for
Huh.
only for the case study.
That is what case study, that in order to tell how many buildings result that you have taken.
Results, sir, 117, sir. Total 117, including residential, commercial buildings, sir, and heavy
So
civil also.
117 that you are considering, only 3 buildings you have validated.
Yes, sir.
So is it a good ratio?
No, sir. No, sir. Actually, I have just taken all the results, and I have just used 3 case studies, sir. Like first is residential, sir. Second is commercial, and the heavy civil.
You
Just
would have,
shortlisted 3.
okay, you would have done the 70-30 ratio in every category, maybe residential, maybe commercial, and maybe your infrastructure project.
Yes.
You would have done this 70-30 ratio, and you
Yes,
have
sir.
done the modeling for 70% and 30% for the testing.
No, sir.
And in your F test, the significance test, one is group and another is ungroup. So what is the
Yes,
F value for ungroup?
56.59, sir.
That is for the between the groups.
Yes, sir.
Okay, only one factor is there. Another
Yes.
factor, what is the difference between group and within group?
So I don't know.
Okay, that means you have made 5 or 6 groups. That is the result between the group, and maybe within the group means which group you have considered, but here within group means. Go back. Go back. Wherein you
Yes,
are you have made that Excel sheet, na, wherein that your A, B, C, D, like that it is there, na.
Yes, sir.
Maybe your group A, B, C, D group, and within that group we have made some questions.
Yes, sir. Yes, sir. ABCD, sir.
A, B, C, D, and within that,
Part A, part B, part C, part D, sir.
that is what. But I don't know what is the between group and within group, and what is the F value you have considered for one, and because for the. Do you have any idea on that?
No, sir. I've consider all the groups, sir.
What a F value represents? And what is that last 0.00?
Sir, P value, sir. It's significant. It indicate the significance, sir. Statistical significance of the study of the factors.
Whether
which I have selected.
that indicates the significance or F value indicates the significance?
P value indicates, sir, significance.
No. See, in your case, that factor is significantly important, but P value, which tells that the error representation, it will tell. So this is a one way only you're done. One way only you're done.
Yes.
And don't know how to read this, because see, degree of freedom, in one case it is 113, another case it is 3. What do you mean by degree of freedom?
Sir, the factors, sir, which the response rate, sir, which I have got.
So that means 117 cases you have considered here.
Yes, sir.
Okay, out of that one, it is total minus 116. But I don't know actually what you mean by between groups and within groups. Anyway, you can once again relook into it. Okay,
Yeah,
you have
sure,
done, or
sure,
you have
sir.
taken the help of any mathematician?
No, sir, I have done this, sir.
So you should know this. Okay then. Okay, thank you.
Yes, sir. Thank you, sir. Thank you.
So any other member wanted to ask?
Can I try again?
Yeah, ma'am.
Can the screen be unshared?
Can you unshare, Syed?
Yes, sir. Yes, sir.
Okay, good.
Is my screen visible?
Yes.
Yes, it is visible.
Okay. A very warm good evening to the Honorable Chair and the participants of this 4th International Conference on Trends and Recent Advances in Civil Engineering. I am Susan J. Chaco, a part-time PhD scholar at Amity School of Architecture and Planning, and I am presenting my topic, which is identification of critical project CPS factors for construction projects in India. So the critical project success factors for construction projects in India, an overview. And this research has been guided by Dr. Charu Nangia and Dr. R.S. Rai and Dr. Vanita Ahuja. The contents of my presentation are the introduction, followed by problem formulation, literature review, methodology, results and discussion, conclusion, and lastly, the references. So I'm going to start with an introduction to the study area of projects. The Project Management Institute defines a project as a temporary endeavor with a definite beginning and end, which results in a unique outcome. And all projects consist of a series of activities and processes which are executed, which are planned and executed in sequence and have to meet certain defined goals and objectives. And project management involves the use of tools and specific knowledge and skill sets to deliver projects in accordance with their defined goals and targets. Now, projects of the built environment. Okay, projects of the built environment are called construction projects, and they involve numerous complex processes which are completed in a planned sequence and which involve numerous stakeholders. As per the Royal Institute of Chartered Surveyors, the standard phases of construction projects are initiation, planning, implementation, review, and handover. And there are numerous processes that go on within these phases. In the initiation phase, we have the project definition, the appointment of the stakeholder teams, and the formulation of the initial project information related to feasibility and the site. In the planning stage, we have the design development and the planning outcomes, such as the technology, the time schedules, the quality criteria, etc. In the implementation, we have the implementation monitoring and the tendering and award of the works and related activities. And in the review and handover, we have all the processes that relate to review and handover of the completed project. So in this study, I am going to look at these factors and processes and try to analyze and rank which are the important critical project success factors that enable successful completion of construction projects. If we look at prior studies, they show that almost 72% of construction projects face delays and about 63% of them face cost overruns. And this is true all over the world, whether in Canada, USA, Netherlands, Malaysia. And in India, the data of the Ministry of Statistics and Program Implementation show that out of a total of about 1,700 government infrastructure projects, each of value above 150 crore rupees, almost 32% face time delays and 84% experience cost overruns. Therefore, there is a dire need to improve the performance of construction projects and enable them to succeed. So what actually is project success? There are many definitions. So some of them are satisfying stakeholder expectations, achieving the project objectives. And some say it is a complex, multidimensional concept comprising many attitudes which differ as per the personality, nationality, project type, and contract types. But the universal definition of project success is that of meeting design and planning goals, providing user and stakeholder benefits, advancing organizational goals and business objectives, and providing lifelong project benefits. So what are critical project success factors? These are the factors that facilitate the successful completion of projects. They are a set of variables which are strongly linked to project success, where their maximization or minimization can lead to the success or failure of the project. And they are mandated to be satisfactorily implemented for success to occur. So we can have a universal listing of these critical success factors, and the proper monitoring and controlling of them can have a great influence on project success. So you will see that while the idea of project management and project success has evolved over time, the concept of CPS factors that affect that success has not undergone much change over the last 40 years. The aim of this research is to look towards enabling qualitative project delivery in the Indian construction industry through understanding the key components for success. And the objectives are firstly to identify the critical project success factors for construction projects, to define the significant project success factors for construction projects in India in relation to the critical risks identified, and to rank these critical project success factors in terms of their importance to Indian construction projects. So in the literature review, several CPS factors were identified, and they were grouped in categories related to project management efficiency, stakeholder engagement, organization for project management, project specifics, project leadership, and the external risks that influence project success. It was found that the traditional concept of project success, where the output-based measures or the short-term measures or target-based measures of time, cost, and quality were not really comprehensive to the definition of success. And therefore, the literature study mapped several outcome or performance-based measures related to user project leadership, project criteria definition, and management of the external risks. Now, you'll find that these outcome-based performance indicators are based on the total quality management model for stakeholder satisfaction and continuous improvement. The critical risks were also identified from literature, and they were mapped in categories related to clarity and project definition, project management aspects such as poor planning and scheduling, poor tendering and contract administration, project execution and site management deficiencies, and also stakeholder related lapses such as lack of team engagement and efficiency, lack of stakeholder engagement, communication and information, and lastly, the risks due to external factors. When these are the critical risks taken out of a series of risks that were mapped. So it will show that most of the risks arise due to poor implementation and planning, these three criteria, and also due to lack of stakeholder engagement. And other key risks pertain to external factors which affect the project and the unclear or lack of definition of the project scope. So this methodology of the study is to, from literature, identify the critical success factors impacting construction projects from prior data, and categorization of these success factors, and identification of the critical risks from prior data. And the critical success factors are mapped to the critical risks faced in Indian construction projects to understand which are the areas where the risks can be contained through the critical success factors. And therefore, we get an idea of the crucial success factors for Indian projects. To validate the study, a targeted questionnaire of key stakeholders and experts was done to validate the study and reiterate the importance of select critical project success factors. And from this, the identification of the shortcomings and improvements in success factors required to enable success in Indian construction projects is derived. So we will find that the success enablers are largely output-based measures, which are short-term measures of success related to project management, and outcome-based measures, which are performance-related measures related to leadership, human factors, project-specific definers, organization for project management, and external environmental management. Now, the critical project success factors that were identified are mapped under the categories. So under project management, we have the project management tools, methods, and processes, and the management of time, cost, quality, knowledge, resources, and contracts, risk management, and handover procedures. Under stakeholder management, we have coordination and collaboration and communication with between project teams and ensuring stakeholder satisfaction. In the organization for project management, we include organizational culture and processes, decision-making processes, and the use of tools within the organization. And in project-specific criteria, we look at the project defining aspects and its performance indicators. Under project leadership, we look at strategy creation, coordination, negotiation, delegation, and troubleshooting within the project implementation. And under external factors, we look at the external risks such as policy and regulatory compliance, market competition, access to funding, etc. So when we map the critical risks that we have identified to the critical project success factors, we try to find which are the success factors that can contain the identified risk. So suppose project feasibility is not prepared or incorrect, it can be contained if we have good organizational processes and defining project-specific criteria, so that process of defining the project-specific criteria is in place. Similarly, for inadequate project leadership, that can also be contained through project organization and processes and ensuring project leadership. And claims and conflicts in projects can be addressed through a variety of CPS factors, such as project management efficiency, stakeholder management, organizational processes, project leadership, and external factors. So for each risk, the critical project success factors have been mapped, which can contain that particular risk. So when we look at individual risks, we find that the risk can be addressed through multiple CPS factors, which are both outcome-based and output-based, which are short-term and long-term success criteria. And in India, we find that a greater overall impact on success is seen through qualitative project management implementation. And this improvement in project management implementation can be augmented by enabling organizational processes, stakeholder engagement, ownership, and external risk containment. The targeted questionnaire survey of key stakeholders in the construction industry was done to collect perception-based data on what are the key enablers of construction project success in India and to rank these CPS factors. So for each CPS factor, the scores from the various respondents were evaluated to a single indicator or index of its relevance to construction project success, which is R. So R is given by the sum, dividing the sum of the respondent scores obtained for each CPS factor by the highest possible score of the CPS factor. And each CPS factor was evaluated on a grade of 1 to 5 on its measure of importance. So looking at the ranking of the significant CPS factors, when we look at project management efficiency, we find that the important factors promoting success are proper workflow and time schedules, definition of quality and its acceptance criteria, proper monitoring and control, and correct handover procedures. Under project management organization, top management support was seen to be crucial along with decision-making processes. Under stakeholder management, coordination and collaboration with multiple teams was very important, along with client engagement and ensuring customer delight. For project leadership, troubleshooting and solving problems was seen to be the most important characteristic of a good leader. And for project-specific criteria, the definition of project goals and objectives was seen to be sacrosanct. And for external environmental factors which affect the project, it was access to funds that was seen as most important, along with resource availability. So we ranked the different factors, and the most highly ranked factors fall within stakeholder management with the rank of 1. So there is a ranking from 1 to 36. And even under project management efficiency, we have very highly ranked factors like workflow and time schedules, quality definition and acceptance criteria, task monitoring, etc. And within the other categories, there are certain very important factors like definition of project goals and objectives and getting better access to funding. If we analyze the top 33% of the factors that fall within the rank of 1 to 10, you will find that 24% of them fall within the category of project management efficiency and stakeholder management. So these include task monitoring and control, quality definition and acceptance criteria, workflow and time schedules, proper workflow and time schedules, proper handover procedures, knowledge management and documentation, client engagement and sign-off, coordination with multiple teams, ensuring customer delight, communication protocol, and information management. The other important factors, as I said, were access to funds and definition of the project goals and objectives and proper troubleshooting by the project team. Secondary enablers ranked 11 to 20 also included proper procurement and resource management, top management support, effective decision-making, establishing project criteria, risk management procedures, and effective work delegation. So this research highlights the deficiencies in success facilitating processes which impact construction project success in India. The inference is that success is multifactorial, depending both on project management efficiency as well as performance-based aspects. And while current construction practice focuses less on these long-term measures of success, they do not give adequate importance to the performance aspects of construction projects. So while we think about raising the standards of project management implementation in built environment projects, which would greatly augment the chances of success, this has to be done alongside with improvements in outcome-based determinants, which will really ensure meaningful success. This is my literature that I studied. Thank you.
Thank you, ma'am, for this wonderful presentation and your clear deliverables. Just I would like to ask you, your study was for this particular paper, your study is to find out which are the areas or any recommendation also you are proposing in this particular paper?
Yes, my recommendation was that the major risks, when we analyze the major risks, we find that most of the risks pertain due to are happening because of poor project management implementation. And therefore, when we look at those risks, yes, there are project management failures, but there are also performance related failures. So my thought was that we should, while we look at cost, time, and quality, we should also look at long-term aspects of performance, like customer satisfaction and ensuring that the project is, sustainable and getting, adequate value for its users.
Okay. Have you came across any project wherein building information modeling is used, adopted, and with this, whatever your results are there, which are better in terms of particular that project, and if you compare with the conventional kind of management system?
Yes, building information modeling, I have looked at it in the context of risk management. And building information modeling is a way to contain risks, because in building information modeling, there is real-time sharing of data between all the stakeholders. And because of that, there is whatever delays there were in earlier processes of sharing information, that is greatly reduced. So everyone is working on real-time data, and therefore that serves to actually reduce a lot of the risks that occur in construction projects. And you'll find that it is greatly used in all infrastructure projects now, like metro projects.
Okay, thank you.
Thank you.
Any other participants or anyone want to ask questions? Then they can ask. Otherwise, we can go to the next presentation. Okay, I think no one is there. We can move to the next presentation. Thank you.
Thank you all.
Okay, thank you, ma'am. Now I request Mr. Rohit to present. And one more thing, we are running out of time, so please keep your presentation within 10 minutes.
Okay, can you hear me, Shivangi? Can you just confirm?
Yes, sir, we can hear you.
I hope my screen is also visible.
Not yet. Yeah, now it is visible.
Okay, so good. Sorry, I'm not a Zoom user, so probably struggling with that. Good evening, everyone. I'll quickly introduce myself first. My name is Rohit Tyagi. I'm presenting this paper along with my colleague, who is Shaunak Mitra. He is head of codes and approvals of fastening solution, and I head the engineering team. I come from an organization, Hilti. We are into fastening and solutions, passive fire protection, and other construction-related hardware, software, and services. So the topic for today is post-installed rebarring. We have been introduced with the cast in situ technologies, and we have been updating the technology in the last many years. Along with that, we also got introduced to many other technologies like cast in, steel structures, and the steel and concrete composite structures. I'll talk about a bit extended technology that is not well versed with the Indian codal environment, but there are already European and other codes which helps us to understand this. So this is about me and the topic of today. So what is a post-installed rebar? It's simply you have an existing concrete, you want to either extend this concrete or you want to enlarge it just to strengthen it, to increase the area of cross-section of steel or probably concrete. So you have an existing concrete, you simply make a drill, you put the chemical, the mortar inside that, you fix the rebar, which is cured, and you are ready to use this reinforcement. And then you can pour the new concrete. So this is how you are using an existing concrete to probably extend a structural member or to enlarge the section. Now, these can be few examples from a photographic view where all we can use this and is getting used. So rebar from a diaphragm wall. Most prominent in the CE projects, the metro projects, where we work on the diaphragm wall first, and then we get this application because of missing rebar couplers. And then we extend the starter bars from the diaphragm walls. So we simply drill, we clean the hole, we put the mortars, and we fix the rebar to use it for the slab starters and the extension. Slab to slab connections, it can be vertical extensions. So you have sliced off your column top. You do not have now the rebars available to extend it to the next floors, next levels. And you simply follow the same process. You drill, you put the chemical, you fix the steel rebar, and you have your starter bars ready. The next image shows you a wall strengthening, where we are enlarging the existing section by increasing the area of steel, plus we'll also add concrete. So generally, micro concretes are used. So generally, micro concretes are used for this technology. Cantilever balconies, if you want to extend something, or slab widening also. This is generally used in the infra road projects, the slab widening application. Now, these can be the probable applications. So any building construction project can be a replica with the post-installed concrete to connections. So column extensions, a beam from a wall extension, it can be a slab to slab extension, balcony, chhajja, something. It can be a staircase connection, a secondary one, wall to slab, new column to slab, slab to wall. It can be any kind of structural connection where you have one existing member which is already casted, which is already poured, and now you want to take out a new member. That's the technology all about. In fact, post-install rebarring forms a critical part of many retrofitting schemes. So there can be 3 ways to retrofit any of the existing structure. And why we need retrofitting, the reasons can be many. The first can be the poor quality of the construction or the construction material. The second can be the aging of the building. It's a old structure and now you want to retrofit or refit this. Another can be the increased traffic volume, load, anything. So in buildings, generally we see that whenever you get a FAR revision, the floor area ratio revision, now you get the liberty to extend to the next floors. And the building owners, they want to utilize this complete space because space is costly. So they want to go high and then they extend the floors by strengthening the bottom floors and extending the top floors. So retrofitting, rebarring gets involved very commonly nowadays, be it building projects, be it the infrastructure projects for flyovers and many other areas. Now, what is the basic principle of post-install rebar connection? The fundamental process and the objective remains same, that I had a cast-in bar which I designed from, let's say, IS 456-2000 in India. Now my post-install rebar should also behave exactly as a cast-in connection, because it will also be behaving as a normal structural connection which we were supposed to cast, or now which we are post-installing. So the idea is simple, that the cast-in bar and the new post-install bar should behave exactly in the similar manner. This is the quick theory about this, that how it works and how it behaves. Basically, if I resolve the forces, so I have concrete, which is the existing member, then I'm drilling, I have the mortar, and then I have rebar. So there are 2 interfaces. One is between concrete and the mortar, and another one is between the mortar chemical and the steel. So this is the simple fundamental and the idea behind rebarring. Now, post-install rebar connections form an integral part of a structure like any other member, which we have established. But the question is, I have different diameters of rebar. Let's say I start working with the 8 mm on the Indian job sites and probably goes to 40 mm also in the heavy construction for the primary columns or for the CE projects. Now, what should be the embedment depth? How much should I drill and how much should I fix this rebar? Then the questions revolve around a lot of things. What is the application? Is it a column from a slab? Is it a beam to beam extension? Is it a slab to slab extension? What exactly is the application? What is the type of connection? Whether it's a simply supported, whether it's a rigid connection, moment carrying. So also depends, is it a compressive forces? What is the load? It can be 100 kilonewton on one connection. It can be 1000 kilonewton also on a connection, which is a kind of raft. So a raft extension generally sees heavy loading. What is the existing concrete dimension? So the orientation of the base material, whether it's a slab, beam, column, what is the grade of concrete, whether it's M25, whether it's M40, whether it's M50, and what are the sizes, what are the dimensions available? So these are few questions that needs to be answered before we get into the calculation and we define the exact depth which is required to make this post-install rebar comparable to the existing cast-in rebar. Now, we will only discuss 3 imperatives very quickly to ensure that these kind of connections are very safe and robust. So first is the product assessment. It is very critical and very crucial to define the product assessment criteria and then to choose the right product. Second, once we have selected the product, then how should we design and what should be the specifications of the product and design. Third, once we have designed, we have defined everything, this should be the depth, this should be the spacing and everything, then how to install this properly. So I will quickly run through the first, which is product assessment. It starts with the selection of the product assessment for post-install rebar connection. Now we have already various guidelines like EN 1990, IS 875 part 3, which talks about the probable design life of a structure. And if you can just reflect to the cursor, so IS 875 part 3 talks that important buildings and structures such as hospitals, communication buildings, towers, and power plant structures, this should have a probable design life of 100 years. So that means whatever product we are supposed to select or whatever product we are assessing should also have an equal life as this expectation. So for that, We have products available in the portfolio which comes with a service life of 50 years and now 100 years. So we understood this pain point and requirement from the market that there are a critical structure category which requires a working life of 100 years. And then the product comes with the working life of 100 years with internal testing which is extended to 120 years also. Because many of the metro projects, especially the metro projects, they are working on a design life of 120 years. So these are the mortars, the chemicals that I'm discussing in last 5-7 minutes. They comes with a life of 100 years with an extension internal testing of 120 years. Please read this ETA as European technical approval. So these products work on the European guidelines that we'll discuss in the later slides. Okay, so this is about the product. The product assessment comes from the European technical approvals. They are having all the performance outcomes of these kind of products, that what is the bond strength for what life 50 year, 100 year, 120 year, the product is assessed and tested. What are the bond strength in different situations for 50 year, 100 year, static, seismic, if it's a normal drilling, the rough drilling, or a diamond core drilling, is it a water-filled hole, is it a dry hole? So all these outcomes of testings and assessments are published in ETA, European Technical Approvals. Now this is all about product. Once I start moving to design and specifications, so the post-install rebar connections can be simplified and bucketed into 3 categories. First is the joints and starter bars. So joints examples can be a column on the slab. Joints can be a beam from the column. These can be few examples of joints. Now the second category is extensions, where you are just extending the existing member. It can be a slab to slab extension. It can be a raft extension. It can be a beam to beam extension. And the third category is concrete overlays, which I was discussing on the retrofitting slide, where you just need to enlarge the existing concrete member for addition of area of steel and concrete. So simply every of the application or structural design can be bucketed into joints, extensions, and concrete overlays. Now, these are the design example of post-install rebar connections, how generally the structural consultants work on that, and how do they define these kind of things in their drawings. So if you can pick to my cursor, it's a beam case. It looks like a continuous beam. I have a column. And if you look at here, the dark portion, they are defining the embedment depth which is required for a rebar to be inserted in the column. So this is the depth which we will drill inside the column to pour the chemical and fix the rebar. Another example here is it's an existing raft slab on the bottom diagram, and we need to have starter bars. So 22 numbers, new holes, starter bars need to be created. So this is how 500 mm embedment depth. Now this is how the structural consultants specify the depths required along with the product which are assessed in their structural drawings. But how does all this work? So we, as a product manufacturer, we have the assessments and outcomes of our products and motors that I have been discussing. And we take the inputs from the structural consultants about the existing members, orientation, the loadings, the type of connection that I discussed already on the animatic slide. So we have the inputs from the consultants about forces, existing members. We have our assessed results for the product. And now we have transformed all this into a software version. So this is a simple software which is called Profis Rebar, which is used for designing this post-installed rebar connections. And that's a diagrammatic view of one of the cases. It's a case of a raft to raft extension or a pile to pile extension. Similar way, there is another example on next slide where we are extending a column from the existing foundation. And you will see all the inputs are considered very nicely in the software when we are considering. So concrete class, 25 Newton. And the calculations are very simple. I'll also show that in just one slide. It's not a rocket science. Basically, what we have done, the things which we were supposed to calculate manually and which we were taking a lot of time and complexities, we have eased that in terms of our software. So this is another example of a beam from a column. You also see the explanation of how the bending moment is happening, how the forces are transferring, and how you are reaching a safe embedment depth in this diagram on this yellow portion. So it explains everything very nicely, that what is the diameter of rebar, 25 mm, what should be the drill bit size for drilling, what should be the spacing, distance, and the depth of hole required. So simply you input all this information in the software, and as an extract, it tells you that this diameter of rebar should be fixed at this much depth, should be drilled and fixed at this much of depth to ensure the robustness of this structural connection. Now, with the fundamental concept that PIR or post-install rebar must behave exactly as cast-in rebars, so it starts from a design guideline, which is Eurocode 2. So if we read Eurocode 2 or Technical Report 023, TR 023, it defines the type of connections that can be designed as post-install rebar connections. So there are different guidelines like EAD, I mean European guidelines, which helps European assessment documents, which helps to understand that how should we design what type of connection. And it is very elaborated and briefed. So the lower portion of the slide shows that how European assessment document EAD 332402 covers the post-install rebar connections with the TR 069 guidelines, which is very recently introduced globally and in European markets last year only. And we are the only ones to have been introduced with this new guideline, TR 069, which extends the type of connections which you can design now, which were limited in the existing codal framework. So the latest launch of TR 069 helps you to design more connections and reduce the embedment depths also. So this is the logic and the simple calculative comparison of a cast-in rebar and a post-installed rebar. So the calculation of depth, which is almost similar as in IS 456 2000 also, the development length required, which is dia by 4 sigma SD by tau BD or FBD, which remains same in this theory also of post-install rebar. But the thing cannot be exactly same because there are multiple other factors which influences this depth. And these are the few factors. So we simply consider 5 other factors into the consideration while using the same formula. And the reason is that it also depends on the existing concrete strength. It also depends on the confinement ratio, which is the clear edge distance and the spacing between 2 rebars. It also influences by the transverse pressure. So whatever considerations can influence this depth or this design connection are considered in the form of different factors, which is from alpha 1 to alpha 5. And then using the base formula of development length, we reaches to this new post-installed development, which is required. And after discussing this product qualification and this design specifications, I'll move to the on-site installation and testing, which is very crucial. So it's very important because we as the structural designers and the consultants, we have used the world-class products, which are well qualified and assessed through the existing guidelines. We have designed them also with the guidelines like Eurocode 2, like the guidelines TR 069 or TR 045, which is for the seismic designs. But what happens if that connection is not installed properly? Because the installation is in the hand of probably the unskilled labor or the semi-skilled ones. So that becomes the most crucial point. And while talking to customers, while talking to consultants, we also understood that there are certain challenges in this installation piece. So time schedule is one, that we need to do things faster. Poor installation quality. So if there is any adulteration in this installation of connection, it can lead to a fatal failure, which can lead to big losses and loss of lives also. Third is the dust. So while you are drilling, you are creating a huge amount of dust, which is a killer for health and safety, and also hampering the environment. And last is lack of skilled labor and right knowledge. So it's a kind of expertise job, which not every unskilled or semi-skilled person can do, but requires a small training and can be done and managed very nicely. So these are the few challenges that we have understood from consultants and owners fraternity. And just to resolve and fix all this, I'll quickly run through a video. It will give you the entire idea of the last 20 slides, whatever we have discussed, that how this technology works. Yeah, thank you. So this was quickly on the installation piece where we were not using the regular drill bits, which creates lots of dust. So we used a hollow drill bit system, which is hollow from inside, not solid, which is connected to a vacuum cleaner. So once the person starts drilling, the vacuum cleaner connected to it sucks and stores all the dust that you are creating during the drilling. That ensures multiple things. First, if the hole is not manually cleaned also, it ensures safety, that there is no dust inside the hole, which can create a bond with the chemical or mortar. Second, it also ensures that you are not hampering your health and safety of the people around you at the job site. And third, a clear responsibility around the environment and sustainability. So this system ensures everything. The next piece of the video was the dispenser. How much chemical should be dispensed? So there is an app which is for our users, which can be downloaded very simply on the mobile phones, Hilti volume calculator, which defines as per the diameter and depth how much ml or volume should be dispensed in one hole. That only ensures the technical feasibility of the structural connection. And then the last piece of video was about the dispenser, which is a battery operated smart dispenser where you can freeze and fix the volume. It dispenses the same amount of volume and auto cuts off. So it's not a manual effort where you're not sure how much volume are you dispensing. It's a battery operated smart tool which auto cutoffs and works on the IoT level of technology. So this was all from my side. Just quickly restating that we used different codes because we have a limitation in the Indian codal environment for the post-install rebar technologies. We refer to the European codes like Eurocode 2, TR069 and other guidelines. Then we use the EAD documents, European assessment documents for the product assessments, their test criteria. And once we are done with that, we publish the results of product performance in the ETAs, which is European technical approvals. So this was all from the codal design and product side. And then we saw a quick video on the installation piece, why it's important to use dustless drilling and the exact volume of the motors. So to understand and learn more about this, we published a book on fastening systems in concrete construction, where the authors are from the organization, Kamalika and Prashant. They are the topic experts working in Singapore and India on the codal and guidelines environment. So this is all from my side. Probably I took a bit extra time, but thank you so much for patient listening. And I can be connected through mobile phone and my email ID. So thanks a lot, everyone.
Thank you, Rohit. It is a very nice presentation, and you have covered all the products of the Hilti and their applications. Thank you. From my side, there is no questions or any query is not there. So if any other one want to ask, they can ask. Otherwise, we can go to next presentation.
Sure. Thank you so much, everyone. Yeah.
Okay. I think there is no question, so we can move to the next presentation. And how many presentations are left, Shivangi?
Sir, 4.
4. Okay. Now we'll stick to 10 minutes time, and I will give 8 minutes for the presentation, and at the last 2 minutes, that is for the conclusion. So after 8 minutes, I will disturb.
Okay, sir.
Okay.
Mr. Prince, are you there? Prince? Okay, he's not there. Next, Hardik Sharma. He's also not there. Shivendra? Shivendra Mani Tripathi, are you there?
Okay, Shivendra. You can share your screen presentation. Okay, we can see your slides. You can go ahead. You are on mute. Shivendra, you are on mute. Otherwise, speak near to microphone. No, we cannot able to hear you. Are you using headphone?
Yes, Sivendra, please use any earphone or headphone.
So now am I audible?
Yes, yes.
Okay, sir. Thank you, sir. A very good evening to everyone.
Please share your
This is
PPT.
Shivendra Tripathi from
Please
Harcourt
share your
Butler Technical
PPT.
University.
Please share your PPT.
View screen offer. Okay, sir. So this is Shivendra Tripathi from Harcourt Butler Technical University. So I'm here to present my MTech thesis paper, which is on the performance of concrete by replacing aggregate with plastic waste generated especially during COVID-19. My presentation contains of the introduction part with the literature review object. The introduction part. The concrete plays a significant part in creation and building of a city, and endurance are used in construction of highways, bridges, airports, railways, tunnels, ports, and harbors, among other infrastructure projects. Concrete has several flaws, including low tensile strength, limited ductility, large weight, and low energy absorption. Due to these drawbacks, civil engineers have resorted to traditional reinforcement in order to improve tensile strength and ductility. As a lightweight aggregate, plastics such as syringes and saline bottles must be used in concrete. One of the goals of producing earthquake-resistant structure is to reduce the unit weight of concrete. Medical trash and infected wastes are examples of biomedical wastes. As per the data collected by pollution control committees, as well as the daily data received from the COVID-19 BMW tracking app, currently average quantity of COVID-19 related biomedical waste generation during October 2021 is about 203 trillion per day till 10th of May 2020. India saw 62% increase in the medical waste, especially PPE kit and glucose bottle and syringes. Improper waste disposals can pollute the environment and create health risks. Proper collection, treatment, and disposal of medical waste not only reduces cost and not only reduces cost, but also promotes a health, but also promotes creates a threat to healthy environment and high quality of life. Introduction to the PPE kit. As we all know, the PPE is known as a personal protective equipment. It was especially we came to know during COVID-19. During COVID-19, this is the data which is showing the use of PPE kit during before COVID and during COVID. The National Disaster Management has established a clear procedure advising all staff involved to wear PPE while coming into close contact with COVID-19 victims, whether proven or suspected. Due to this single use, due to its single use, the increase of PPE kit resulted in a huge waste generation. As a result, medical waste creation jumped from 40 to 50 tons per day to 47 tons per day, according to the researchers. One of the drawbacks of reusing PPE kit is that the efficiency of virus isolated material decreases after cleaning. Advantages of PPE kit in concrete. The PPE material utilized in the trials are of good quality and are easy to work with. Additive employed in this study had a significant impact on concrete strength. The materials in PPE kits have a low specific gravity. The thermal conductivity of the composite is found to be lower than that of normal concrete, making it an excellent choice for use as a thermal insulation medium in tropical climates. When compared to other construction components, the PP based composites exhibit superior performance in compression, tension, and flexure. The medical wastes. The medical waste is a subset of garbage produced by healthcare facilities such as hospitals, doctor's office, dentistry places, and veterinary clinic, as well as medical research institutes and laboratories. 8 billion vaccine does have generated an additional 144,000 of tons of waste as per WHO data. Waste from microbiology and biotechnologies, sharps such as hypodermic needles, syringes, scalps, and shattered glass should be disposed of properly. Medicines that have been thrown away and characteristic substances. Advantages of medical waste in concrete. Most significant benefit of this partial replacement is the overdump of hospital medical waste on it. As the percentage of medical waste was increased, as the percentage climbed, so did the density, because medical waste ash has a lower specific gravity. The compressive strength of the specimen 5% ash is significantly higher than the control mix. Significantly higher than the control mix samples had compressive strengths that are comparable to the control mix. PPE kit used concrete as sand. PPE kit, the personal protective equipment, face masks, including gloves, was one of several socio-economic outcomes used during COVID-19 epidemic. As a sequence, this disposal sector has grown dramatically. Several studies that looked into waste management concerns from differing viewpoints, such as local authorities and trash collection firms. According to the findings of numerous studies, nearly 60% of local authorities in the country region have implemented particular procedures for the processing and collecting of trash PPE. Due to the increased expenses of modifying collecting schedules, 15% of trash collection business have used special collection schedules for waste created at quarantine collection stations, and 25% of waste PPE kit have been thrown in waste landfills, causing numerous infections. Use of PPE kit shows some advantage according to some researchers. PPE materials are utilized in trial and are of excellent quality. The elements in PPE kit have such a low specific gravity, and they are used as filler in the concrete. Glucose bottle used in concrete as aggregate, coarse aggregate. Cement producing also produces harmful gases, including dust, which have the ability to degrade air quality and cause a variety of respiratory illness. As a result, various studies have been conducted in order to find a unique alternatives methods of dealing with this environment issues. Plastic bottles were employed as the major component in the creation of concrete blocks, such as medical waste, glucose, and waste plastic water bottles. This is my literature review, which helped me in lot while preparing my thesis, while doing my all this work. Ms. Lubna K. Hamada in 2021 in his research He looked at how waste needles could be used to partially substitute natural fine aggregate in concrete mixture. He replaced the fine aggregate with 0.2%, 4%, 6%, 8%, and 10% by weight, respectively, by the waste needle which were produced. The concrete mix were tested as 7, 14, and 28 days of cure. The workability, fresh and hard density, compressive and flexural resistance, water absorption, leaching tests were all completed. The WN's concrete mix showed enhanced flexural strength and workability, lower water absorption capacity, and improved durability according to this study. Maria Rashidi in 2020, in her research, she aimed to determine the effect of utilizing expired plastic syringes as fine aggregate on the fresh and hardened qualities of flow-able concrete, which could help to address environmental concerns. 6 flow-able concrete composition with water to cement ratio of 0.38, that is 4:5, were investigated. It was discovered that adding up to 20% recycled aggregate to flow-able concrete mixture improves workability and increases V-funnel values. In 2022, Ms. Priyanka Yadav, in her trials and measurements were carried out in this study to assess the efficiency of the waste plastics reused in concrete construction. In 0%, 1%, 2%, 3%, 4%, and 5% concrete blends, waste plastic were used to partially substitute sand. At room temperature, the concrete cube were examined. This research shows that the repurposing plastic waste such as fine coats, aggregate substitutes will cut material costs while also addressing the waste disposal issue.
Excuse me, Shivendra. You are requested to kindly skip the literature review and come to your work because we are having short of time.
Okay, sure.
Yeah.
Coming straight to my testing, mixed formulation. So what I did, first of all, I made a mixture of first of all I replaced coarse aggregate with a percentage of crushed glucose bottles with 3%, 6%, 9%, 0% respectively. And then with keeping the mix for testing of concrete at 0% replacement of sand with varying percent of coarse aggregates. As you all can see, this is the 0% PPE kit which was been replaced with sand. That is, a pure sand was used with the replacement of coarse aggregate with 3%, 6%, 9% in the mix in specimen model 1. Then the mix for testing of concrete at 3% replacement of sand with varying percent of CGB. In this, the PPE kit, 3% of PPE kit were replaced with the sand, and varying crushed glucose bottles were replaced with coarse aggregates. And the same goes with the 6% replacement of sand with varying percent of CGB, and the same goes with the concrete at 9% replacement of sand with coarse aggregates, varying percent of coarse aggregates. This is the result that has been noted. The crushing value of aggregate due to partial replacement of aggregate with crushed glucose bottle occurs maximum is 29.84% and minimum is 24.6%. Maximum crushing value occurs at 0% replacement and minimum at 9% replacement. Coming to the impact value, the impact value of aggregate due to partial replacement of aggregate with crushed glucose bottle occurs maximum is 31.87%, and the minimum is 23.91%. Maximum impact value occurs at 9% replacement and minimum at 0% replacement. Abrasion value of aggregate due to partial replacement of aggregate with crushed glucose bottle occurs maximum is 36.73%, and the minimum is 32.73%. Maximum abrasion value occurs at 9% of replacement and minimum at 0% replacement. Coming to the slum tests that were conducted, maximum value of slum for concrete samples have 0% crushed PPE kit and 9% of coarse crushed glucose bottle is 118 mm. And the minimum value of slump for concrete samples have 0% crushed PP kit and 0% of crushed glucose bottle is 109 mm. Coming to the mixture model 2, that was the 3% crushed PP kit and varying percent of crushed glucose bottle. Maximum value slump for concrete slumps having 3% PP kit and 9% of CGB, that is your crushed glucose bottle is 119 mm, and minimum value of slump for concrete having 3% crushed PP kit and 0% of crushed glucose bottle is 109 mm. Maximum value for slump for concrete samples having 6% crushed PP kit and 9% of CGB is 120 mm, and minimum value of slump for concrete sample having 6% crushed PP kit and 0% of CGB is 109 mm. Maximum value for concrete samples samples having 9% crushed PP kit and 9% of CGB is 121 mm, and the minimum value of slump for concrete samples having 9% crushed PP kit and 0% crushed CGB is 109 mm. Coming to this compressive strength of part, the maximum value of compressive strength of 7 days for concrete samples having 0% crushed PP kit and 9% of CGB is 22.53 Newton per mm square, and a minimum of compressive strength for concretes having 0% crushed PP kit and 0% of CGB is 19.24 Newton per mm square. Maximum value of compressive strength of 28 days. The blue one represent over the 28 days for concrete samples having 0% crushed PP kit and 9% of CGB is 34.46 Newton per mm square, and minimum value of compressive strength of concrete samples having 0% crushed PP kit and 0% of CGB is 29.42 Newton per mm square. The maximum value the maximum value of compressive strength of 7 days for concrete having 3% crushed PP kit and 9% of CGB is 23.10 Newton per mm square, and minimum value of compressive strength for concretes having 3% crushed PP kit and 0% of CGB is 19.24 Newton per mm square. The maximum value of compressive strength of 28 days for concrete samples having 3% crushed PP kit and 9% of CGB is 35.32 Newton per mm square, and a minimum value of compressive strength for concrete samples having 3% crushed PP kit and 0% of CGB is 29.42 Newton per mm square. The maximum value of compressive strength of 7 days for concrete samples having 6% crushed PP kit and 9% of CGB is 23.55 Newton per mm square, and minimum value of compressive strength for concrete samples having 3% crushed PP kit and 6% of CGB is 19.24 Newton per mm square. Maximum value of compressive strength of 28 days for concrete samples having 6% of crushed PP kit and 9% of CGB is 36.01 Newton per mm square, and a minimum value of compressive strength for concrete samples having 3% crushed PP kit and 6% of CGB is 29.42 Newton per mm square.
Shivendra?
Yes, sir.
Can you conclude?
Sure, sir.
Because see, these are the repetition of the graphs that you would have done in the one particular graph with showing that 0 to 3 or 3 to 6, whatever 3 to 9. So one bit in between one basic question for the crushing test, how much load is applied? Shivendra? We lost you, I think. Kindly check your connection. Shivendra, are you online? Shivangi, can we take it between other presentation?
Yeah. Praveen, are you there? Praveen?
Yes, sir.
Yeah, please, can you present now?
Pritesh, we request you kindly take only 10 minutes.
Okay, sir. Okay, sir. Sure.
Highlight on your work and your result and discussion, and then the conclusions. No need of going
Okay, sir.
in literature review.
Okay, sir. Good evening, sir. My name is Pritesh from Dr. D.Y. Patil Institute of Technology, Pimpri. The topic of our paper is U-boot technology in construction sector. Firstly, now we cover all the contents from the introduction, literature review, methodology, research and discussion, conclusion and references. Now we firstly introduce shortly for our U-boot technology. It is recycled polypropylene formwork technology used for construction. Means it is made up of recycled polypropylene. It is box-like structure which will fitted into the concrete, which increase the strength of the concrete and reduce the concrete weight. It creates highly economical. Means initial investment is high for this reason. It is made this contains two-way slab. Now we focus on what is U-boot technology. Now we focus on what is U-boot technology. It is wide form of workplace in between top and bottom. The main advantage of this U-boot technology is to form a network of slab between very strong between two layers of the slab. Instead of concrete, we can put U-boot beton. Beton is a structure which is made up of recycled polypropylene. The basic research in the field of reinforcement concrete structure have focused on enhancing the span either by reducing the weight or overcoming the concrete natural
because more the concrete will produce the strength, but in case of the, it will be very heavier in the high-rise building. So it causes reduce the number of floor in the building. So therefore we use the material like a U-boot beton, which is simple one structure made up of recycled polypropylene used in the building construction. So it will increase the strength of the slab as well as the structural member. Now, next slide. There are two types of U-boot beton, that is single U-boot and double U-boot. So single U-boot is generally it is based on the slab thickness. This slab thickness we have generally this U-boot beton size is generally standard size for slab. That's why we taken this standard size for U-boot beton, which is 52 into 52 centimeter, and height varies from 0 to 56 centimeter. Therefore, we use the standard size of U-boot beton. Next. There are three types which joins the U-boot beton interlinked in the concrete. The reinforcement in the concrete contains this U-boot beton connected each other by various joints, that is spacer joint, which is stroke like structure which connect between two beton intermediately, and the connection bridge which covered the connect plate like structure which connect between two betons, and third is closing plate. Now next. Now literature review. This is literature review we have thought, but it is later slab structure which is splitting the reinforcement concrete between two slabs, which gain the strength after the placing of U-boot beton in between them. In the floor mushroom-like phase, we have known the mushroom-like structure, which is single pillar and huge. The column mushroom structure is column-like structure, but its upper section is broader than the bottom section, which cover the larger area of slab and reduce the number of columns for the single slab. It helpful for us that the number of free space available is more because the number of column is reduced. Therefore, we use this type of structure. This all the research paper we have studied, and from that conclude that all these structures are using, but mostly the U-boot beton is not applicable to construct because the heavier load comes at the corner section of the column, corner section of slab where the column is situated. Therefore, we have to construct it in the middle portion. Now we have to focus on methodology. Firstly, in the U-boot beton, which is single unit, and all these are connected to each other, and they are placed in reinforcement, and the reinforcement spread over on it, and it will be installed. Now, second is spacing of concrete slab of U-boot beton. The U-boot betons are covered with the full of concrete, and the concrete spread over them, which will reduce it will need the concrete, but reduce the quantity of concrete. Now, third is next. Now, third is removal of formwork. Removal of formwork, which means it will also use in simple RCC structures also, but it is also used in U-boot beton. Now, the data provided by Doliform company is that whatever steel we have used in the slab, pillars, and foundation, and in concrete used in the slab, pillars, and foundation, reduce the quantity of this material and increase the strength. It is the numerical data present here, which will shows the strength or quantity required for the U-boot beton. Now, load distribution. Load distribution in now majorly we have already tell that the U-boot beton is not spread on the corner section of the U-boot beton. So we have used the axial tension and bending tension in the middle. So it will take a load of vary because we have a profit of applying U-boot beton is that it increase the number of floors, means increase the load capacity of a floor. So the bending and shearing stress. Now it will also helpful in, as we told, that reduce the number of columns, beams, and the number of pillars in the large section. Now large span, but pillar spacing is increased, thickness reduced. These are all advantages are included in the wood beton. Now next is this is the proper way to increase number of floors, and here is second picture suggests that the gap between pillars is increased 1.5 into whatever gap we provide in the simple RCC structure will increase to 1.5%. It will increase from the previous age, and number of pillars or beams column decrease in last section. Similarly, when it provides a large number of floors, it gains maximum strength. Next. Second most advantageous is that it is fire resistant, which means it protects from fire at any time. Means if any fire occurs in the building which is made up of U-wood beton slabs, it will resist the fire. And similarly, it is sound insulation, where the noise pollution are major concern, where we use the. Now come to the result point of view. After testing the different specimen in the concrete block, advantages and beneficial it is mostly using it. Due to the major initial investment, it will not in India. So therefore, we have the structural behavior of this new kind. Monolithic flat slabs will be same as solid slab. Now U-boot technology save amount of concrete and steel, and also possible to reduce the self weight of structure. Next. It is architectural and eco-friendly. It will not harm the design of the any structure which will be present in the building. Now we conclude that this reduce the concrete and increase the strength of a building, and also save the larger space of the larger space. Therefore, beside that, let the reduce dead weight up to the 50%, which allows create foundation size smaller, avoiding the cement. Environmentally green and sustainable building we can produce it. Sir, now we have a short video which will demonstrate how it is working.
Pritesh, we can see this video because it is 6 minutes. So anyway, it may be available on YouTube or that we can see. No issue. You can come to conclusion straight away.
Yes, sir. Yes, sir. We can conclude that, sir. It will reduce the recycled plastic, replace 100 kgs of concrete. It means whatever concrete we use in major concrete, it will reduce the large span of concrete and gaining the strength more than the concrete, which means whenever we required in small space, we required large number of floors. It will also helpful in that place. And beside that, it also reduce the dead weight of the building up to the 45% and 30% based on the construction. Now it also sustainable for long time and reduce the concrete and increase the sustainability up to and durability of the structure. It will helpful in the increase the durability of lifespan of the structure up to 4 to 5 years than the simple RCC structure. Thank you.
So Pritesh, is this technology is used in India?
No, sir. No. Only 1, 2 places where it will, but it's not fully used. Only 1 to 2 places which is partially used.
So in your opinion, whether this technology is suitable for the Indian condition?
Yes, sure.
So it is satisfying all the criteria of thermal comfort, fire resistance. Pritesh? Okay, I think we lost the connection again. Pritesh? Okay.
Praveen, are you there? Pritesh.
Okay, Pritesh. Okay, anyway, we lost the connection. So any more presentations are there?
No, sir. We are done for today.
Okay, whether Shivendra is available, so he wanted to conclude, and if you want to add anything to his presentation, he can add. Shivendra?
I think he also left.
Okay. So anyway, thank you. Can you read out, Shivangi, the presenter name and the paper ID?
Sir, of whom? Of everyone?
Everyone in this particular session, 4 to 5:30.
Sir Rajesh Kumar, paper ID 177. Then Syed Tihamuddin, paper ID is 166. Then Miss Susan, paper ID 132. The next one is Syed Mihas, paper ID 165.
165. Okay.
The next one is Shivendra Mani Tripathi, paper ID 99.
Okay, and Preetham, last one.
Preetham is paper ID 175.
Okay. Okay.
And
you.
Rohit Kumar also.
Rohit Kumar. Rohit Kumar, whether it is a sponsored presentation or it is a part of your conference paper?
Part of the conference itself.
Okay,
Paper ID is 17.
17. 17. Okay. Okay. Thank you for this information, Shivangi.
Okay,
so,
thank you so much.
So in this particular, to conclude with this session, in this there are 7 papers are presented, one from particularly industry-oriented paper and other paper which covers the aspect of the construction technology and the sustainability aspects. So all are presented very well. So there are maybe some problems with these technical problems, connection problem. Because of that, we have lost in between also. But the all presentations were nice. There are some errors are also there during the experiment that also I have observed, but I have not mentioned here. But anyway, so nice to see you here, and all the best for your future. And I am thankful to the organizers for giving me this opportunity to chair these sessions. If anyone want to ask anything, so they can ask. Otherwise, we can disperse with this session. Is it okay, Shivangi, or any announcement is there? Shivangi, any announcement is there?
No, sir. No, sir. Anyone has to ask anything with the sir? Or else we can conclude now.
Okay, then we can conclude. Okay, thank you.
Then that's it for today. Thank you so much, sir.
Thank you.
Okay, thank you everyone. You can leave now.